Welcome to the 3D printing seminar. Really happy to have you here. This is exciting stuff, and I want to acknowledge our seminar sponsor, Matt Wells, with Scale Motorsports. Would you stand up?
Hold up, you can sit down now, Matt.
Nobody said you could stand up.
Yeah.
So, what you're going to hear today is an expansion on what we started 2 years ago. We did our first 3D printing seminar on GSL 24, and it was an eye-opener for us. And we think this is going to be even more of a shock to your system. We hope it is. We've got a stellar cast lined up to present today. We've got some really, really great people. And I want to give you an idea of what we covered in that first seminar, just as a kind of a heads up as to where we're going. And you can watch that seminar at the GSL website library. I believe it's still up. So last time we talked about the CAD systems that create the digital 3D models. We talked about service bureaus who actually print out 3D models into 3D printed parts. We talked about the finishing of the models. We introduced TDR Innovations, which manufactures designs and prints parts via Shapeways. And we talked about do-it-yourself printers and showed you the Event-A-Part RigidBot, which was a Kickstarter campaign back in 2013. And we're going to have a RigidBot here to print parts later in the seminar. So on your table is 3x5 cards. If you want to jot down a question or two as we go, at the conclusion of each presenter, you can send those cards in, and we'll read the cards and record the answers as well. So, okay, I want to introduce our seminar by showing you a video done by a company called C-Ideas, which is a construction of the 1927 Miller race car. So this will orient you to 4 of the technologies in 3D printing, and it will show you the CAD model and the finishing techniques. So a lot of the finishing techniques are processes you're already familiar with. And go ahead and roll number 1.
The best way to put it would be that I'm a huge car guy, and my friend Bill Gould, who's a fantastic designer out of California, is also a huge car guy. One day he was showing me some of his portfolio, and I happened across this Miller 91 car on his website. I didn't realize that it was something he actually drew in 3D CAD. It was quite an amazing feat, really, and I just knew immediately that I had to build this. When we set out to build this car, we wanted to highlight the 4 major technologies in 3D printing. That is FDM, which is fused deposition modeling, SLS, which is selective laser sintering, SLA, which is the original invented 3D printing process, stereolithography, and PolyJet. With the FDM process, it works like a hot glue gun extruding a hair-thin strand of plastic. It's a computer-controlled head that draws the perimeter of an object and then raster fills it layer by layer. In the case of this model car, when we did the frame, we actually built it in 13 thousandths of an inch layers. That enabled us to build it quickly, but also still maintain the strength and durability of ABS plastic. The polyjet process utilizes inkjet-like heads, and it jets out an acrylic photopolymer that has UV bulbs on either side of the head. As it jets it out, the lights are actually curing it into a solid. Letters we did in polyjet because we used one of the elastomer materials called Tango Gray. That allowed us to actually press fit the letters into the tire. The SLS process is a powder-based process which uses powdered nylon, which has the consistency of baby powder. What we do is we inert a large chamber with nitrogen, and a 70-watt CO2 laser imprints the image of each layer into the powder by melting it. The SLA process is the oldest 3D printing process. It was created about 30 years ago, and it utilizes a 200 milliwatt laser, which is curing UV sensitive resin inside of a vat. when we chose to do the spoked wheels, we also used SLA, and we chose that because the surface finish of the model right out of the machine was good enough that we could just lightly sand it and spray it with the final color. The head of our model shop, Sue, did most of the pattern finishing. And pattern finishing is where you take a raw 3D printed model and you sand it, you sometimes bondo fill it, or you'll use sandable primer to fill up the layer lines or reduce the layer lines, and then get it prepared for either paint, plating, or vacuum metallizing. It was really cool to finally see all the parts in one place, and the day that we did the final assembly was the very first time that all those pieces were in one place, because we utilized 4 different processes and we had to send parts out to be chrome plated and vacuum metallized. And so when we finally got them all put together in that one room, that's when it hit me that when this thing goes together, it's going to be really impressive. What's so amazing about 3D printing, especially for doing a model like this, is it makes you realize that anything can physically be 3D printed. And this model is just one very small example of how great this technology is and some of the great things that can come out of it. Once we actually got to the trade show, the very first one that we presented it at, when people come to see it for the first time, they immediately say, well, what on this was 3D printed? And we said, no, the entire model was 3D printed. And usually people have a hard time accepting that. To be able to 3D print this entire model and have it look like a real car, it was just amazing to me. This was a great project that we got to work on, and I really want to thank Bill Gould with GouldStudios.com, Rebel Form, and Vacuum Code out of Michigan for helping us out. But mostly I want to thank all my employees and the Build Parts team for really pulling through on this, and this model turned out fantastic. I mean, I couldn't be prouder, and I can't wait to see what we build next.
Did that get your attention? Oh, what fun stuff. Real quick, I forgot to introduce myself. I'm Lynn Koberna, and a couple of housekeeping items. Please turn off your cell phones. And then I want to give you a brief outline of where we're going and what we're doing today. So our first person is Bob Wick, and he's going to be talking about the 3D printed GSL awards. And then we're going to have our keynote speaker, Andy Cohen, who is extremely knowledgeable and extremely opinionated about 3D printing. Okay? And then we have Chaz Cochran, who is one of our own. He's one of our pioneers in the car modeling field. with 3D printing, and he is also extremely knowledgeable and extremely opinionated. So then we're going to showcase some 3D printed model car parts that are done by the contestants in this particular GSL. So they're going to talk about their experience with printing, whether they did it themselves or used a service bureau, and show us their parts and give us a quick showcase of their work. Then we're going to have a stretch break. This thing goes 2.5 hours. So at about 2:30 we're going to have a stretch break, and then we're going to have shift from some of the do-it-yourself to the commercial service bureau type services. Our guests are Kerry Parker and Chris Flowers from White Clouds, which is a local Utah service bureau. And then we're going to have Don Hendrick, who was here a year ago. Don Henriksen was here 2 years ago and purchased a rigid bot, which was introduced in the Kickstarter campaign by Eventapart. And if all goes well, he'll be printing parts live for us to see, and he's going to talk about that process of do-it-yourself 3D printing. And then we're going to have a quick panel, and then we're going to talk about the future. So that's the outline. I'm going to have Bob Wick talk about the awards for GSL.
Well, welcome to the seminar. This is going to be very quick. I just wanted to put this in context in terms of how all of this 3D stuff got brought into GSL and why it worked for us and what it did. If you've been here for the last couple of championships, you've been through the initial phase of coming up with a model kit to build your own award when you won a place. It started out as gator board, cut by hand, assembled into little packages. The ultimate goal was to do it as a model kit. So we had injection molding, which is obviously very expensive to do. We had resin casting as a possibility. And then we ended up looking at 3D printing. And part of this, I wanted to thank Chaz Cochran and Lynn. They were both very, very helpful and very dedicated in the beginning of this process, taught me a lot. Chaz ran out some of the early pre-production prototypes so we could develop it, contributed his experience and knowledge about how to make it better. And then Andy Cohen, who's the keynote speaker, is the one who, in California, actually printed out the 3D awards. So this year we actually do have a model kit. The sprue is really just kind of homage to the traditional injection molded stuff that we've done, but it looks more like a model kit than just individual pieces do. So anyway, that was what I wanted to do. I wanted to put it in context. This is what GSL has done with it. Today you're going to see what other people have done with it. So anyway, learn, pay attention, and ask questions. There's a lot of technological and finicky detail that you'll have to get used to dealing with if you're going to do 3D printing and prepping the materials, files, how you're going to put it together, what material you're going to use, all of those kinds of things. So if any of that stuff isn't clear to you as you're listening to this, or somebody touches on something and you don't get a satisfactory explanation, by all means ask those questions, because it becomes critical when you're dealing with new materials and new procedures and processes that you're not used to doing, to find out that technical stuff. Otherwise it starts to come apart or it doesn't work the way you wanted it to. So again, thank you for coming, and I'm going to turn this back over to Lynn.
Thank you, Bob. I encourage you all to read the bios of our presenters today. We don't want to take the time to do that right now. I just want you to know that Andy Cohen has a podcast and a website. And how many printers do you have?
Well, 9 and counting.
9 and counting. So I'll let him tell you a little bit more about his background. Pay attention. Andy.
Thank you for having me here. I'd never heard of, can you guys hear me okay?
Yep.
I'd never heard of the GSL competition before. And when I found out about it, kind of felt like this sounds like I may have found my tribe. I'm a model maker since I was a little kid, and although I'm not anywhere up to par from you guys. I went through your exhibits yesterday and today, and I'm stunned. And of course, the first thing I think of is, how could I do that with a 3D printer? And I'm going to try to share that with you today. As Lynn said, I'm very opinionated. How many of you guys have 3D printers? I own a company in Sebastopol, California called eStop Plus, which is actually a Radio Shack. It's the only Radio Shack in the country that sells 3D printers, 3D printer materials. I am not here to sell you anything. I'm here to give you. I'm not selling anything, I'm just going to give everything I possibly can. I also am the producer and co-host of what is the only 3D printing technical podcast there is. If you're interested in 3D printing, strong recommendation is listen to the podcast. The material for how to work a 3D printer is not out there. You have to hunt and peck to find little bits. My co-host and I, we bring it all together and present it every week for about an hour on our podcast. So that could end up being one of the best resources for you. But I'll talk about resources in just a bit. It was a challenge for me to figure out what the goal of this presentation should be. So I'm going to have to try to wing it. I don't know how deep I should go technically, so I'm going to do this as quickly as I can. This is like putting your mouth to a fire hydrant. I have 3 hours worth of material I have to condense down to what is now less than 50 minutes. What I like to make, I got challenged a while ago. People said, well, we can make a little dinky plastic toys in a 3D printer. And I set out to prove them wrong. And the way to do that was to print electric guitars that are as playable, if not better, than wooden guitars, but which can't be made with wood and router. Hence, you see my latest Stratocaster up there. It's a semi-hollow, plays just as good as a $2,000 Stratocaster. It's got cutaways, which can't be done on a router. I also like to make large statues and exhibit them in my shop. I made a 2.5-foot high version of the Winged Victory statue from the Louvre. I've done statues from artists, like you see here, the Tetra horse from an artist in Israel called Dizengoff. You start getting into 3D printing, you'll see Dizengoff's work more and more. In fact, I have one you'll see in just a moment. I also like to make models. So that's the B9 robot out of Lost in Space. That's one of my submissions on Thingiverse.com, which you'll hear about more and more today. But I also do a lot of commercial work. I found after 2 years of nonstop printing stuff off of Thingiverse, it wasn't enough any longer. I had a lot more printers. I have staff that are into 3D printing. So we started taking on commercial work. And some of the stuff we've done include these trophies that I did for you guys, which I'll talk about in a little bit. By the way, if you're lucky enough to get one of these, listen carefully. Don't bend it and break it. Get yourself an X-Acto knife, heat it up over a flame, and cut it with an X-Acto knife. Okay? This can delaminate. You don't want that to happen because these are hollow. They're hollow with hollow infill. Use Tester's plastic cement to put them together. If you're going to paint it, a quick spray with a primer, sand it down to the plastic, you just start to see the plastic, and then put your color on it, and it'll come out looking like glass. So overview, we're going to talk about 3D printing in general. I'm going to be able to jump through that real quickly thanks to the film. And I'll give some details on the 3D printers that are out there that you guys can have in your home. You don't have to do what they showed you in the video. I don't know if you guys realize this, but they were showing you 3D printing machines there that are the size of a house. Yeah. And you know that vehicle that they made a model of? Yeah. For less than what they spent making that model, you can make a real race car that runs on gasoline and goes around the track. Be aware of that. Then we're going to talk about what it takes to make a print. I'm going to run you through the task flow, and I'm going to give some of you some critical pointers that are not obvious, that are not published yet, that you might want to scribble down or at least keep in mind and give you motivations to listen to the podcast. And then I'm going to tell you how to get 3D objects. These are some of those industrial machines. So I'm just going to zip right through this because we've seen it all. And by the way, the powder jet, inkjet stuff, they use that for the Paranorman movie. Any of you guys got kids or grandkids? They use 3D printing a lot these days for puppets in stop motion animation. I have a daughter who's a stop motion animator, so I get the scoop of what's happening in the industry. The powder bed inkjet printers use a gypsum powder and very, very high accuracy for color. Actually, it would be an excellent printer for making models, but it's very expensive and they're becoming obsolete very quickly. Selective laser or sintering, SLS or SLM, is what you'll get with the very high-end expensive machines, and this is the kind of printer you should expect from a printing service, which you'll be hearing about a little bit later. And then there's another technique called laminate object manufacturing, made by a company called MCore. Is a fascinating new approach which is taking over the market for the movie industry. It uses regular reams of Xerox paper, which run through an inkjet printer, compresses with white PVA glue, and then an electronic razor cuts out the image. It comes out to be as strong as veneered wood, and that's an example of a hammer that I tried at CES. It actually hammers in the nail. It's extremely strong and fully colored. You couldn't tell it was 3D printed. And the image in the middle, the black, but that's another Dizengoff structure made using SLS. The reason why SLS is so incredible is you get really, really durable material, but it's fully supported with a powder. So you can do geometries and shapes with no limit. Of course, you have to be able to get the powder out of it, so you got to leave a hole in there. But otherwise, that's its strengths, but it's very expensive. To do the equivalent guitar body that I did on my printer for about $40 would cost well over $1,000 for SLS. You've already heard about the methods, but I want to point out on the left side, that's the FDM method. One thing about FDM that we're going to be talking about today is as the stuff comes out molten, you want it to come out nice and soft, molten liquid, pure liquid, and it comes out and it's got to fuse with the plastic underneath on the side and then immediately harden. So that's the process you have to master. Most of it's done automatically, but if you don't understand it, things can go wonko on you. And you really got to start with understanding what's happening with FDM printing. SLA printing, which we'll talk a little bit about as well, is probably the optimal for GSL models, GSL quality models. But we'll talk a lot about that later on. They are not as available for home use yet, and there's good reasons. So if we compare some of the stuff you saw in that video to some of the stuff that you can buy today for your home, the price differences are enormous. Usually for an industrial machine, it's a couple $100,000. The materials, you have to use their materials, you have to use their software, you have to ride in their bus, which means you're at their mercy. A part can cost as much as $1,000, easily. Whereas with the prosumer hobby market, I show there it's $600, that's no longer valid. Today I'm hearing that within the next few weeks you'll be able to buy a good printer, I mean a good one, there's a lot of bad ones out there, and I'm going to tell you which ones to avoid, for $275. Okay, pretty good deal too. And they go as high as about $7,500. What's the difference? Well, we'll talk a little bit about that as we go along. Mostly it's build area and toolpath quality. However, in the prosumer hobby bots, you have to take responsibility for what the machine's doing. You have to do the settings, you have to get the materials, you have to understand what's happening. And I can't say this any stronger. It's so much fun, and it's so addictive. It sounds like that's a negative, but from where I stand, that's the major positive. In and of itself is the most amazing, thrilling hobby I've ever been involved in. And when you get your first print off the printer, your head explodes. It's like getting a hole-in-one. It's amazing. It truly is amazing. Few machines have any safety features. So you need to understand that. Plastic's like wax. It's volatile. It can light on fire. And it's possible for a part to pop off the plate and get stuck to the hot end. So you have to be able to monitor. You can't leave it unmonitored with nobody around. It's dangerous. And you need to also understand that the industrial side's closed source, which means you get no access to what's happening inside the machine or the software, whereas the prosumer hobby right now is still dominated by open source, which means a lot of really cool stuff is free. And I'm going to show you what that is. So some of the myths versus facts. Those large industrial 3D printers make better prints than the hobby desktop printers. That's true if you don't want any involvement. If you want to take your model, drop it in, push a button, and walk away, yeah, you'll get a better print. Yeah, you get a better print if you want to spend the money. It's possible. But I would tell you, and the fellows from the service bureaus would probably look at me and laugh, I could match the quality with my home desktop 3D printer doing it the way I've learned how to do it. I can easily match the quality. It takes some skill, it takes some knowledge, and I'm only going to be able to give you a taste of that today. Another myth is 3D printers made by a big name brand are always going to be better than the ones you've never heard of. It's the exact opposite. Okay? Have you ever heard of MakerBot or 3D Systems, Cube Pro? These are bots to avoid. These companies have a business model where they want to capture you and not let you buy any materials from anybody but them. They use only their software, and their bots just don't work. So it's actually the opposite. Today, we're dominated by open source machines built by folks like yourself, hobbyists that are getting into the business. So there's a lot of pitfalls and a lot of landmines to watch out for. But it's an extremely exciting time right now for 3D printing. 3D printers emit poisonous fumes. Well, that's arguable. The particulate matter that comes out of a 3D printer depends upon whether or not you're using the heated build plate. Those of you who print in ABS, it comes out with a really yucky plastic smell. The heated build plate makes it outgas, and it fills the house with a yucky chemical smell. But particulates, it's about the same as frying bacon in your kitchen. Still, always open a window. Always put the bot where there's good ventilation, or you don't want wind or cold air blowing on the bot, that's bad. But keep it ventilated. Some people actually put a vacuum draw out to the window just to make sure. PLA, which is the other popular filament, which we'll be talking about in a bit, it smells like sugar or waffles. Doesn't mean it's better for you. It smells good, but you still want some ventilation. Is it poisonous? It's questionable. Nobody really knows yet. SLA printers is a different story altogether. SLA printers use a resin, liquid resin, and as it's curing, it puts out a chemical which can be very dangerous. You will get sensitive to it. SLA printers you do not want in your home on your desktop. You want them in the garage or in a shop with a lot of ventilation. Also, the chemical that they use for the resin is potentially very dangerous. My daughter, who works in the animation as a fabricator and as a puppeteer, she says that the experts are telling her if you get the resin on your fingers, it goes into your body, and your body can't remove it. So resins are dangerous. Be careful, especially the stuff you make molds with. Potentially very dangerous.
They always have that?
Yes, they always have been. And the SLA printers did not solve that, not at all. 3D printers can manufacture guns, that's true. They can. They're just not very good guns. I would never shoot one. I'd be afraid of losing my hand or have to blow it up in my face. You can easily build a gun yourself using one of the machines that we heard about earlier this morning, lathe or mill, just as much easier than you could a 3D printer. And 3D printing has been way overhyped. It's true. It's been way overhyped, and if you're watching the stock market, it's currently been corrected. The stock values of all the big companies have crashed. Now's a good time to get in. And on the other hand, it may have been overhyped, but it hasn't been overhyped in its potential. You really can manufacture almost anything. You really can. So if you're a modeler, this might be for you, because it's pretty exciting. So there's a big difference between closed source and open source. And these are the three printers today that are the known closed source. There may be more out there, but they're below the noise level right now. The one with the most noise level is MakerBot. MakerBot's the one out of New York, from Brooklyn. They're the ones that kind of splashed the market 2.5 years ago with the Replicator 2, which I have two of, by the way. This is the Replicator Gen 5. This is a no-buy. I tell people, do not buy the Gen 5 bots. The Mini, the Replicator, and the Z18, stay away from them. I'll be saying that again, and I can tell you why if you're interested. The PrintXY is a closed source machine, but you can bypass how they do their closed source part. And the bot's made by a company that understands how to make laser printers. So it's a pretty good bot. And a pretty inexpensive bot, too. It's like $500. So if you're interested in getting a cheap 3D printer and you're interested in hacking so you can use any filament you want, or just use their filament, the Print XYZ is not a bad printer, not at all. And the Cube, at first I was like, ew, it's made by Cube, it's made by 3D Systems, but I met with the folks from 3D Systems at CES, and I saw the light. This particular model Cube, the entire path from the spool all the way to the hot end where the stuff squirts out of, when you switch spools, that whole part, all of those get replaced, which means all of the most important parts of the printer are brand new every time you change the spool. The quality of the prints are excellent. The downside, they make you pay for that. It's expensive. So if you don't want to learn anything about 3D printing, but you want a 3D print, that's one method you can do. I'm going to tell you other methods later on. Open source. Open source is where all of the action is happening right now. Open source, there's hundreds of makes and models, and the reason for that is because the designs are published and they're free. Any college student that understands a little bit about it can buy the parts for 50, 60 bucks and slap it together and use free software, free firmware. The bot you see on the upper right is the Prusa i3 or Prusa i3. It's the most popular kit out there, probably the most popular 3D printer out there. It's based on the original RepRap design, which we'll talk about in a second. The bot on the bottom is the original open source maker bot called the Replicator 1. It's a dual extruder. Wouldn't recommend buying it today. I would suggest buying the clones from China over this bot. But it was fully open source, and since it was open source, the manufacturers in China were able to take that design and fix it, make it work correctly. The thing that you should understand is that there's really two camps in the open source world. There's the Marlin firmware, and there's the Sailfish firmware. They both work great. However, the Marlin firmware is at its height right now. It can't process faster with faster processors, where the Sailfish firmware can go, instead of just 8-bit processors, can go full 32-bit processors. And that makes a difference when you start to speed the printer up. That's kind of important. So if you want a printer that you may want to use in a more advanced manner in the future, you probably want to focus on the Sailfish firmware-based bots, and these are usually the ones that are based on the Replicator. Also, you should know that all the controller boards that you have in all these open 3D printers are based on off-the-shelf Arduino board designs. Anybody here know what an Arduino board is? Arduino boards are Swiss Army knife controller boards for controlling sensors, effectors, and motors. They're sold as hobby kits. I sell them in my shop. If you're going to build yourself a robot, you're going to get an Arduino board. That's why we call our 3D printers bots, or maker bots, because they're based on robotic controller boards. And they've all come from these general purpose, fairly poorly designed controller boards, which means some of the earlier bots, these controller boards, if they short out, will burn up. So be aware, you're not buying a polished, quality product like we used to build at Hewlett-Packard. You're not going to get that. You're going to get something that will work, but if you make a mistake and you plug something in while it's still turned on, it could zap the entire board. There's no protection circuits, there's no overheat circuits, so keep that in mind. Now, the more advanced bots, and I'll be happy to answer any questions about what bot you might be interested in, will have some of those controls in there. So it all depends. So what to look for in a 3D printer? First, you need to ask, what are you going to be printing? An FDM printer that uses plastic filament may not be ideal for you. If you're going to be printing the bodies of the cars that you're going to be making, you do it in FDM. If you're thinking of engine parts, well, my friend Chas here, he's been able to show you can do it in FDM. But if you're going to do some of the extremely tiny quality stuff like I see on the dashboards of your models and parts on top of the engine block, you can only go SLA because it's so small. It's too small for FDM. So keep that in mind. There are SLA printers, but they're not as affordable as FDM printers. The size of your support community is critical. If there's no support community for the printer you're looking at, don't buy that bot. No matter how good a company says their support staff is, they're not going to be good enough. And what you want to be able to do is say, hey, I have this problem, the temperature's not going up, something's wrong. You want to be able to go to a group of people who've already had that problem and solved it. So if you're interested in the bot and you're not sure, do a quick Google search to see if there's a forum and how many people are on that forum. You want to see where that bot's produced. My favorite bots are all made in the USA, with only 2 exceptions. And I'll tell you why in a little bit. You want to be able to easily upgrade it, fix it, modify it. My favorite analogy for a 3D printer today is a 3D printer is like an RC airplane. You need to be able to put it together. You need to be able to fuel it, tune it. You need to be able to learn how to fly it, and then land it. And you need to know how to fix it when you crash it. All of that's exactly true with 3D printing. Okay? You are going to crash it. Be prepared. And that's half the fun. What to look for in build area, we'll talk a little bit more about build area. I'll zip through it. But the X and Y, the flat two-dimensional axes are actually more important than the height, the Z-axis. As you go higher, the probability of failure goes way up. So the higher the part, the more of a gamble you're making. Because you can go into 8 hours into a 10-hour print and have it fail. It's not fun. It's really not fun. The hot end, the type of hot end, we'll talk a little bit about hot ends in a bit. There's different types of extruders, which we'll mention, and there's a variety of toolpath control. That's the method of making the print head move around. The build area, so you can see the printer on the right has a very tall build area. That's the Wanhao 5, by the way. Also sold as the Fusion Tech, one of the vendors I deal with quite a bit. I would not buy that bot, because I would never go that tall. That's a big mistake. I got the version that's about 1/3 that height, and it's plenty big enough. And also, how the bed or where the part is attached to the printer is something to take into account. And you'll notice the Prusa i3 on the left, it has the bed going backward and forward. That's the old rep style. Whereas the printer bot, the metal symbol in the middle, it uses the x-axis, which goes left to right. Whereas the MakerBot Rep 2 on the right, it does it with the z-axis. So the object goes all the way up and slowly drops down. And it turns out, and I think I agree with this, that for speed and quality, your best bet is to do it the way the Replicator 2 does it. However, you can still get excellent results with the other 2 methods, but you may need to go a little slower. Consider the entire object is moving around. You know, and mass. The more mass you have, the more likely it'll move a little bit. So you want to minimize that. So here's some hot ends. This is probably the best hot end on the market, although it's been modified quite a bit to improve it. It's the old Mark 7, now Mark 8 MakerBot hot end. It's an all-metal filament path, utilizes a direct drive. The filament actually flows down into this yellow part. That fan there keeps that pathway cool, and then the hot part where it turns liquid is right there. And that's what you want, because what happens is as this guy's printing, the filament's going up and down. Because as the hot end travels, you want to suck the liquid plastic in, otherwise it drips down onto the part. Now, if it's liquid up higher, when it shoves it back in, it's going to go and clog your extruder. So you really need to keep the plastic filament really cool. That's why there's a fan there. You need to keep it cool and liquid only right about there. And the reason why a metal filament path is so much better is because if you go to more exotic filaments, you're going to need a higher temperature. And the ones that use filament paths that are plastic or Teflon can't go that high. Here's another very popular hot end called the Ubis, made by Carl Ubis. It's a peak barrel. This is it on a printer bot. Very inexpensive and easy to use extruder. It uses a direct drive feed mechanism, which is really easy to see. I have a couple of printer bots that Brook Drum gave to us for the show. And they're not the fastest machine. They're not the most amazing machine. They put out good enough parts. What I love about them is you can sit there and watch exactly what's going on. And that turns out to be the most interesting and important part of 3D printing. If you can't see the printer, you can't see what's going on, you don't know whether it's coming out correctly. This is probably the most popular hot end on the market right now, called the E3D V6, also called Volcano. Here's a cross picture of it. Here's where the plastic's liquid and it's kept hard through here, and you can see there's a fan there and heat sinks. It's a fantastic hot end. You can go lightning fast on this hot end, and I'll show you some bots that actually use this. You can actually buy a bot and replace the hot end with this hot end. So a lot of people do that. Here's the different feeder methods. There's the direct, like the printer bot had, where it draws the filament into the hot end directly above the hot end. But there's also another method called Bowden, where the motor which drives the filament is off on the side, and the hot end's all the way down there. Now, in order to make that work, you've got to properly set your retraction, so it's going to suck the filament much, much higher up. So it's just a matter of settings. It works almost as good, but my preference has always been for the direct drive. I've got a couple of bots that use the Bowden approach, and I've always been able to get better results from the direct drive machines. That doesn't mean that the Bowdens are not as good. It just means that I'm used to doing my settings for direct drives. By the way, this is a Delta bot, which we'll talk about in just a little bit. Very different styled 3D printer. Very sexy looking. Okay, in toolpath control, your goal is to control backlash. If you look at this part, which I printed, and to my dismay and horror, I get what's called ringing, or this is called, or fading. It's like a fading ring. And what's really going on there is the hot end is coming up to where that hole is on that layer, and it stops, and then it zips across, and it stops, and it's vibrating. And then it keeps going. And those little things are the vibration in the toolpath control. So how do you control that?
So moving left to right?
Yeah, it's moving left to right, and it's going, and you get that little bit of vibration, and you'll get these patterns in your print. And a really good 3D print, you won't see that. You also won't see a pattern in the lines along here. Here there's a slight wavy pattern, but you could also see patterns that go this way kind of wave, and that's from Z-height control. And so how do you control these extraneous movements? Well, one could argue for GSL quality, you may not care about this. Because I would suggest to all you guys, what I would do is I would print at my finest quality, prime it, sand the primer off, you won't see any of this. None of this really matters. But in case you're curious, there's at least 7 different styles of toolpath control, starting with the RepRep method. Those of you who don't know, RepRep stands for Self-Replicating Rapid Prototyper. The name came up from the group in Bath, England. The moment the patent ran out of FDM's 3D printing, these guys got together, made a group, and said, let's make our own 3D printer. And they did it all open source. They put the plans out there. And this is an excellent example. This is the Mendelmax printer. Used to be the #1 printer only 3 years ago. Only been 3 years. Today, that same approach, one of the best out there is the Lulzbot Taz, the one on the right. My local makerspace has 2 of these printers. They're pretty good printers, but I probably wouldn't recommend them. And if you're wondering why, you'll have to ask me. This is inside of a replicator too, and in here, instead of the base going forward and backward on the y-axis, the y-axis is actually happening up in the gantry up above. The x-axis happens with the carriage left and right, and as I mentioned earlier, the z-axis drops down from the shelf. This is my replicator too, and it's very heavily upgraded and modified. It's my first bot. I'm very proud of that bot. It's printed amazing stuff. This was a very popular bot called the Ultimaker, and they do a completely different style of toolpath controls out of a European country. I'm not sure where. The rails here spin, and there's no motors moving along the path, so there's no mass. So that little vibration has nothing to shove, no mass to shove it forward. That's the theory anyway. The downside, though, is if there's any distortion in these rails, the bot will show that in print, and that happens a lot, unfortunately. There's an Ultimaker 2 that has come out since they put this bot out, and that is definitely not on my recommendation list. And if you're curious, you have to ask me, but I don't recommend buying it. This is the PrinterBot Metal Simple. This is a wonderful little bot. It sells for $600, all metal. It's built like a tank. Note that this is GT2 belt right here, a little belt. It's not a loop. It's a single path belt, which means the gears only engage once. So there's no slop in the system. So you get really good toolpath control. The bed goes to the left and right. You get a 6 by 6 by 6 inch build area for $600. This is an excellent first bot. Highly recommended. I've sold about a dozen of these bots. None of them have come back. All the users love them. Now, these are some of the more advanced toolpath techniques. This is the method used by the MakerBot. It's called HBot. Now, this is not necessarily a bad technique of toolpath control. The problem is it really torques the case. In other words, it really pulls on the gears. So the case that holds these gears together has to take that into account. And of course, the engineers that build the MakerBots ignored that. They just went ahead and did the toolpath method like that. And so you see that in the prints. That's tweaking the case and breaking the case, and it makes it very loud as well. Some of the engineers out there saw that and found the alternative design, which now makes an optimal toolpath control called Core XY. Now you want to remember that because Core XY is the wave of the future for 3D printers. Core XY has a method of toolpath control that has the minimal backlash, so you won't get any of those vibrations. How that works, you'll have to talk to me later, otherwise it'll bog down the presentation. It's Core XY. I'll mention a couple bots that use this technique. So what to avoid in your first 3D printer? I strongly recommend staying away from crowd-funded startups. I know somebody talked about that 2 years ago. We're going to see the result of that tonight, or this afternoon. I strongly recommend against it for your first bot for a number of reasons. And by the way, Kickstarter, Indiegogo are some of the biggest crowdfunding sites out there. It looks like you're getting a bargain if you're an early adopter. Looks like you may be getting a big percentage off the price. What you're actually getting is a pre-beta unit 3D printer. You're getting a device that's not fully baked. It hasn't been beta tested yet by a bunch of folks who typically don't understand things such as sourcing and channel control and production methods. They just buy the parts, sit in their garage, and put them together. So you'll get minimal support, if any, and you may not see your award for a long time. Now that doesn't mean you shouldn't do crowdfunding. I'm just suggesting that you don't do it if you're looking for a bargain in your first 3D printer. That's a mistake. If you're going to do crowdfunding, the reason for crowdfunding should always be you want to support these guys and help them turn into a company. It shouldn't be, I want a cheap bot. There are cheap bots out there. You don't have to do it through crowdfunding. I would suggest strongly you stay away from all of the new maker bots. They've done so many things wrong in their design, such as they sealed up the hot end so you can't clear it. It clogs up, they tell you to buy a new hot end for $250. Stay away from maker bots. That's three models, the Mini, the Replicator, and the Z18. The Z18 looks like the most amazing bot. I get people calling us all the time with serious problems. Stay away from them. Cube Pro was actually a design purchased by another company, not Cube or 3D Systems. It looks like the most amazing quality bot when you look at it. It's metal everywhere, all chrome steel, gorgeous bot, doesn't work for anything. Don't even think about it. That doesn't mean that the little cube is no good. Little cube's a good one. Never buy your printer off eBay. It's your first printer. I'll give you a horror story. One of the more popular replicator clones is a company made by Flashforge, called Flashforge. They did the FlashForge Creative 1 and FlashForge Creative 2. And when that came out, I bought one of the earliest versions. And after about a year, they started appearing on eBay. And a bunch of folks bought them. And things went wrong. Wires break. One of the weakest links in these 3D printers are the cables that reach to the hot end, because they're moving around. They're going to break. And unless you design something that makes the cable all move at the same time, that one little spot's going to break on you. And so that was happening. And these guys complained about it, and they called up FlashForge. And FlashForge says, well, what's your model number? We don't know that model number. And they bought them off of eBay. I strongly recommend you don't buy a bot off of eBay. Also, if you're on any of the websites that sell broker stuff from China, don't buy that way. If it's your first bot, that's a big mistake. You may get a great bot, but you'll get zero support. Any support you get, you'll have to be able to speak in a different language, call them in the middle of the night, and they may not be able to help you anyway. That doesn't mean that all Chinese-based bots are bad. I'll show you one in just a minute, which is a good one, or two of them. More things to avoid. I can't stress this enough. Marketing materials. Ignore them. Even the best bots out there, their marketing materials are meaningless. They don't say anything about the quality of the bot. They may tell you that the resolution is really small, half a micron. It's nonsense. They all use the same motors. They almost all use the same hot ends. They differ in subtle ways. And the way to find out if it's a quality bot is not through their marketing materials, especially their feature lists. And if you're looking at things like bells and whistles such as webcams or internet connections through a browser, such as the MakerBots, don't do that, because they'll put all their time and money into these bells and whistles and the bot won't work. You want a bot that focuses on one thing and one thing only, printing reliability. If there's no way to upgrade the bot, there's no way to be able to put a glass plate on the bed, you don't want that bot. If there's no way to use a standard format that everybody uses and they force you to use proprietary file format, that's not a bot you want, because you'll be forced to use only their software, in which case you'll lose a lot of control to be able to make the quality part that you're going to need for your models. Kits for a first-time operator, I strongly recommend you don't do, because you don't know what you don't know. So you might put the thing together and you won't know why one axis looks junky, because you've never seen it working brand new. You don't know how it works when it's ideal. You don't know the optimum design. Now, it doesn't mean a kit's a bad idea. I've built 2 bots so far, and I'm looking forward to building another one. It's just for your first bot, you might find yourself a little lost. Now, if you have people out there to help you, you'll be able to get past that. But if not, you may end up with a bot that may not work for quite a long time. I've got a friend of mine who's in that boat. I suggest staying away from 3mm diameter filament. As it gets thicker, it gets more brittle as it gets older. As it gets closer to the end of the spool, it gets tighter and tighter and tighter. And if you don't use it all up right away, you're going to be throwing spools of filament away because it breaks before it makes it into the printer. Whereas 1.75 diameter filament maintains its flexibility a little bit better over time. You always get better results with the thinner filament. All of the hot, exciting new filaments are 1.75. So I would recommend stay away from 3mm. That cuts out the Ultimakers, the Lulz bots, the Air Wolf. So be careful. Think about it before you buy. These are questions you should ask. And before, I would say, if it costs less than $500, chances are you're getting a bot that doesn't have end stops, which means it's a piece of junk, you don't want it. Well, I'm going to take that back, because I found out this morning, actually, that Wanhao just produced the i3, $275. All my friends online are screaming and yelling about it. My favorite guru out there is one of the beta testers, got a thumbs up. $275 for a working 3D printer is pretty darn good. A good working 3D printer. So here's some bots that I do recommend. Some of my personal favorites. Type A Machines bot. This is all folded steel, incredibly rigid body, a 12-inch by 12-inch by 12-inch build area, It uses the same toolpath methodology that the replicators do, an all-metal filament path. This thing's a prosumer beast. It's beautiful, has all sorts of neat things about it, but the most important thing, the two fellows that run this company have brains in their heads. If you modify it or break it, they'll help you fix it. They'll give you free parts. The service level is amazing. The amount of groups of people involved that use these bots are huge. People build printer farms with this bot. So you'll see rooms filled with them. It's pretty exciting. Type A machines. It's out of San Leandro, California. Sorry if that sounds biased. These are the printer bots. Now the printer bots are out of Lincoln, California, right outside of Sacramento. Very popular bot. They used to be all wood. They're made to be less expensive, so they have to be tethered to a computer. There's no independent display and control on them, but you can do some fantastic quality prints. One things that make these bots stand out from the others, I don't know if you can see the little yellow dot right there. You can see that? That's an inductive sensor. So with this bot, you don't have to adjust the bed. It senses where the bed is and knows to level it automatically. So it does some neat stuff for you, and it does work quite reliably. I have a couple of the metal simples. My son has one, and I have one. I've sold about a dozen of them. Very, very reliable bot for a good first bot. Now, the bot on the bottom is the Fusion 3 F306. An acquaintance of mine produces and sells this bot. This is a true Core XY machine that uses the E3D Volcano hot end I mentioned earlier. This is even a higher level prosumer bot than the TAM. Fantastic machine. The only downside, it's $3,700. Get what you pay for. By the way, there is another Core XY machine out there called the CraftBot, and that's a crowdfunding nightmare story. They finally got their product out about 2 months ago, and they're going bust. So people who got their bots, they won't be able to get extra parts or get them fixed. So crowdfunding, I don't recommend. Here's the Replicator 2 again. I have 2 of them. I upgraded them to almost all aluminum parts, so if you can find one, I don't recommend it, but if you can find one, you can probably get them discounted because they stopped making them. And then you throw in another $600, you'll get it at a bigger discount than $600 because they're used. You throw $600 and remove all the plastic inside to aluminum and tune it up, you get one of the best machines out there, but you really got to know what you're doing. This is the CNC Orion. We have one of these. Well, this is a solid machine. It's a Delta. They also make a giant one called the Max. Very well supported. A huge group of people out there use them. Maker Gear is out of the Midwest. It's an all aluminum and steel body, extremely rigid, really well made, excellent bot. And now the Wanhaus and the FlashForge are the Replicator 1 clones. They're made in China, but they're high standards, and they have distribution networks and warehouses in the United States. So spare parts are available, support is available, and there's a huge community of users for both of these bots. So it'd be a thumbs up for Wanhao and FlashForge as well. And they're pretty inexpensive. By the way, the Orion is about between $1,300 to $1,500, depending upon where you get it. The Maker Gear is about $2,000. The Wanhaus range from around $750 to about $1,200. Now, these are some of the better-known SLA machines. These are the hobby-level ones. Now, be aware that SLA's been around a long time. So there are SLA 3D printers out there that are in another realm, and there's hundreds of them. But they're sold to jewelry makers and people who use them professionally, so they're not inexpensive. They're pretty pricey, but they're fantastic quality. They're not designed for folks like us. But these are. This is the Form Labs, the Form 1, that started as a Kickstarter about 2.5 years ago. Today it's evolved into a real product. It's a thumbs up. Eventually, we've been promised one for the show, so eventually we'll be talking about it on the show. It ain't cheap though. It costs about $3,200. They're not easy to use. They're a little bit trickier to use than FDM. They smell like the dickens. You got to wash the part off because it's soaking wet with resin. You have to pull supports off. So there's downsides to SLA that outweigh the value that you get from it today. That's about to change, though. We'll talk about that in just a bit. The Pegasus is about $3,000. It's a little bit less expensive, a much bigger build area. But each of these SLA manufacturers, you have to use their resin because the light sources that they use, they design their resin to match the frequencies and power of their light sources. So I'm pretty sure the Formlabs is laser. The Pegasus uses a DLP, which is similar to our projector that we're using here today. The B9 Creator is a kit, and you can see there's the projector down there. You get the kit that includes everything there except the projector, and you go buy your own projector. I don't recommend it. A bunch of my friends have built them, and they do work, but it's pretty complicated. And this one right here is made by the same company that makes the Da Vinci that we showed earlier in the closed source slide. That's going to be around $1,500. It's going to be out sometime this year. Just about out of time. These are the filaments that are out there. You can see the list of PLA is huge. Note, there's a couple of filaments in there that you guys should get excited about. One is, where is that? Steel filled PLA. So it prints just like plain old PLA. Printed at a really fine quality. Take your part and rub the plastic away. It looks like stainless steel. Not as strong as stainless steel, but it looks just, well, it is stainless steel. It actually is stainless steel. So you get that polished look. It's really pretty. Another one that should be exciting to you guys is Ninja Flex, known as TPE or TPU, made by a company that does fan belts, so you can actually print your tires. Big real rubber-like tires. It's pretty exciting stuff. PLA is my favorite, and I would suggest PLA. Chaz says no. Chaz says it could melt a little too easily. My experience building electric guitars is if you do it right, don't leave it in your car on a hot day with the windows closed, you'll be okay. Chances are if you use an ABS model car,
Not good for a model car.
yeah, it's not good for a model car of any type, I would bet. And I don't think you guys care about this, but some of the more exciting filaments, nylon is almost indestructible. I print a lot with nylon. PET is made the same plastic that we use for our water bottles. It's incredibly high quality plastic that's getting more and more popular. This is where the future lies. This is where we're moving. It's PET. Much, much higher quality, finer quality. But again, for GSL quality prints, PLA, in my opinion. Some of the, well, let's zip through this. So some of the tasks, well, you're going to make your part, you might use CAD versus other software. Here's an important difference between what is CAD. With CAD, like SolidWorks is a good example, you'll get a part that's made of elements that the CAD software understands. So you'll get elements of circles and squares, and the CAD software sees the object in a proprietary manner in its software. And that can't be 3D printed. You can't print from that directly. Instead, you have to transfer the file into what we call a mesh. And a mesh takes that geometry and turns it into facets and triangles. And once you get into that kind of a representation, any changes you may make to that mesh are dangerous because you could break it. In fact, it could be broken even before you make any changes to it, which is why sometimes you need to verify your mesh using special software tools. These are some of the CAD packages out there. There's a big difference in CAD I want to talk about. There's non-parametric versus parametric. How many of you guys use CAD software? How many of you guys use parametric CAD software? Okay, non-parametric CAD software is like cutting metal or wood. If you made the hole the wrong size, you have to go back to that step where you drilled the hole and do it again. Parametric software, you change the size of the hole directly and it modifies everything within reason. So I would suggest to anybody thinking about getting into 3D design, go directly to parametric. It's just as much to learn. It's just as easy or as hard to learn as non-parametric. And then you'll bypass the issues of non-parametric. Now, Here's the good news. It's free. It doesn't cost a penny for hobbyists. SolidWorks costs a lot of money. It's the most popular CAD package out there, followed by AutoCAD, which is non-parametric in many of its versions. If you look at the bottom, there's I'm running out of battery. There's two CAD packages. You may want to write them down. Fusion 360 and Onshape. Both are free to hobbyists. Both are parametric. Both are in the cloud. So you don't have to dump all the software onto your machine. And they are a blast to use. Okay? Now, once you've done your design, you made your design, you can transfer it into mesh. Well, there's a way to solve the problems of having a mesh object, and that's turn it into what we now call voxels. Anybody here ever heard of voxels? A voxel's a 3D pixel, like a pixel. It makes up a picture. And it turns out with voxels, you get fantastic quality organic shapes. So you can take your mesh, switch it to voxels, make some changes, turn it back into a mesh, and you get a really good quality mesh. You want to learn more about that? Listen to our show. We talk about it all the time. Our favorite tool for that, by the way, is a program called 3D Coat, which is about $70 for hobbyists. Not that expensive. Also, there's a program called Blender, which operates on mesh objects. It's free. It's a little complicated, a little hard to use, but we talk about it on the podcast all the time and teach you how to use it. And there's lots of tutorials out there that are free. Okay, am I out of time? Close. There's ways to capture the object. There's 3 techniques. One way is using structured light. One of the products with structured light's the Sense. You can also use a Kinect camera off of an Xbox or an Xbox 360. These use a pattern of light, pattern of dots, and through algebra it calculates the 3-dimensional spot of that dot and then builds a point cloud, and the point cloud then gets transferred into a mesh. So you can actually capture a person. A structured light's excellent for catching people because if they move, it updates it. The other type of capture is desktop laser scanners. These don't work as well. I'll have questions afterward. I'm almost out of time. These don't work as well, unfortunately. I would not recommend them. The matter-informed scanner I have, and I'm only getting acceptable scans today after owning it for about a year and a half. So I don't recommend them. However, there is a holy grail for scanning. It's called photogrammetry. And with a good single lens reflex digital camera and the right lens, on a cloudy day, you can walk up to any car and throw the files into the software, and you get a detailed 3-dimensional model, which you then have to chop up and turn into something that's printable. And that ain't easy. That takes some skill. Maybe in a couple of years we can talk about that. We talk about it on the podcast. But photogrammetry is the way to go. Agisoft's PhotoScan is one of the best ones out there, written by a guy in Russia. AutoCAD has a package out there that runs on PCs and in the cloud for free. So if you've got a good camera and you want to learn how to do this, AutoCAD's 123D catch. I'm going to zip through here. There's freebie software that you use to control your bot. They also slice the objects. So once you go from mesh, you need to slice the object into very thin slices. There's commercial software that I love to use that actually does this for me called Simplify 3D. That's my favorite. There's also NetFab, which fixes meshes, although I don't recommend it. It's overpriced. These are the settings you would do in the slicer, probably going a little bit too deep here. There's primary settings and secondary settings. Primary settings you would probably do for every part. Secondary settings would be for every spool. This is a picture of the effect of layer height. You can see, well, it's hard to see, but this one's supposed to be really smooth. That's 0.1 millimeter. The effect of infill, this is 15% and 75%. Hard to see, but these are shells. So you can control that much of the 3D print. And it all depends upon your object to figure out how to do it. And there's also the effect of how you position the object. So there's support material that gets printed with the object to keep things up. Otherwise the stuff prints into air. And how you position the object really affects the quality of the print. So you'll see the default approach, this is the object that gets printed. The default approach, which would have a raft and support material, well, that slope that you see right here with the support material would come out all bumpy and junky. You don't want to do it that way. Instead, some of us purists would offset the wheel onto the bed and sink it so the curved part of the wheel that you see on the rim is below the surface of the bed. And then we print that, flip it upside down, and sink it again so only the rim that I didn't print prints again, and I glue those two parts together, and I would get a perfect finish. But there's another way to do it, which may be even better, that we're all exploring these days. Instead, put the wheel on its edge and go full support. And this way, the support is at a good enough angle so that the plastic doesn't get the supports shoved in there, which then ruins the finish. This actually works pretty well. Highly recommend trying it. There's a way to obtain the objects. If you're interested in 3D printing, I should warn you. This first one, Thingiverse, I refer to that as the red pill. Have you ever seen The Matrix? Beware. You go there, you're doomed. It is a YouTube of things. You'll get sucked in and you'll never get out. You'll be, I gotta get a printer. I gotta print that. There's robots, there's RC cars, there's drones, there's so many awesome things that you can print. There's household things, switch covers, special parts for your cars, and it goes on and on. Every day there's about 100 objects uploaded, and everything's free. Okay? GrabCAD is a more traditional website that has CAD level files. 3D Content Central is a website that has parts that companies put up. So you have like a washing machine that has a part, you can get the file to actually 3D print it yourself instead of buying a part. And it's surprisingly pretty comprehensive. It's been up there for quite a while. Anybody here use McMaster-Carr? It's a hardware distributor, one of the biggest out there. All of their parts have CAD files. You can 3D print them in nylon and almost as strong as steel. And the others that are up there are things that people sell, parts that are available, toys and statues and artwork. You'll get lost in them. There's over 30 websites today that we know about. I use plain old Testors model cement. Anything that works on a plastic model kit will work on PLA and ABS. Vapor polishing is good for primarily ABS, but you can also do it in PLA. If you listen to the website, the podcast, we tell you how to do it. I use regular paint. Testors model paint works great. I also use the Rust-Oleum on my guitars to get a nice thick finish on it. There's another product that's basically a resin. I don't recommend it. It gets kind of yucky looking. Don't recommend that product. Here's a model car that I tried to print. I downloaded that file from GrabCAD, a beautiful model. If you're interested in seeing how awesome these models on GrabCAD get that model and check it out. It's gorgeous. I tried to print it for you guys because I thought, oh, I'm going to show off. I'm going to do something that's GSL. I ended up with basically only this part. If you want to come up and see it, I'll have it up here. This is the hood element. The geometries got too complex for my CAD package, and I couldn't get adequate extrusions on it, so it didn't come out. The bottom piece is on underneath. But it is easily feasible to make your own body panels. And there's some 3D printing services you're going to hear more about in just a few minutes, White Cloud and Shapeways in particular. There are others out there, so if you don't want to get a 3D printer, but you want to take advantage of 3D printing, this is a great way to go. Most of these services, such as the top ones, use SLS, so you'll get the really super quality, excellent print, which you'll see. However, there's a bunch of guys out there like myself that if you go on 3D Hubs or Make XYZ, you can contact them. They're usually in your neighborhood. You put in your zip code, and you can meet up with them, and for pennies in the dollar compared to Shapeways, you can get them to 3D print for you. So you don't have to have your own 3D printer. You can have people print for you. What's coming? Well, I think we'll talk about that later. I'll save that for somebody else. What do you think? Some great resources. Again, I have show cards up here. Come up later and grab one. We're the only 3D printing podcast out there that goes beyond gabbing about money. We gab about money, but just for a few minutes. It's mostly tech related and how to 3D print. Our numbers have taken off. Companies throw printers at us for review. Filament companies throw samples at us. So we are becoming the force in hobby level printing. So check it out. You'll get a kick out of it. There's also local makerspaces. Do a Google search. There's usually a makerspace in your neighborhood. There's Google Groups. That's probably the primary source of how to fix your printer. Instructables.com is a fantastic website for kits and parts and things. And of course, there's Thingiverse and GrabCAD. I think that's it. Thank you so much for listening.
As Cochran, and he is on the court with model building and 3D printing. And Chaz, if you could wrap that up, let's go till 2:40. Did you do that? Okay.
Oh, welcome along. About 2.5 years ago, I bought my first 3D printer. It wasn't about this hobby. It had nothing to do with the hobby. I got into it to work. I'm disabled, work out of my home. Got connections with Kellogg's. We taught. The nearest hobby place, or not hobby, but 3D printing place was Detroit or Grand Rapids. Nothing in between. That's 170 miles between the two, in the area. So we got together, we talked. One thing led to another. I called, did the homework. That's the thing I'll touch on a lot is homework. You want to do your first 3D printing? It's all homework. You talk to the people, call them, tell them what you want to do. For one thing, 99% of them can't do what we're doing. Plain and simple, right now. The first company I got with and really went with them after contacting MakerBot and everybody else who basically gave me some guy from Japan or Afghanistan that I couldn't understand, and anything else, could not do it. Plain and simple. When you say 125th scale, they look at you and say, what? Okay. We're taking a machine that was produced back in 1980s and we're re-engineering it, reverse engineering it to get to what we want. We got a gentleman here that he's got rims. 2 years ago, these rims could not be done accurately. And believe me, I get thousands of emails from everybody from here on in the modeling world about rims. Custom rims, one-off rims. We want one-off rims in 125th scale. Can't be done. Sorry about your luck. They can be done accurately. I can give you 4 rims that's going to give you mentions of 4 different measurements. And they're not all going to fit the Pegasus rings. One will fit, one will be too big, one will fall right through the thing, and the other one will be oblong. And they all are oblong. And that came from, actually, Shapeways. Had the same problem 2 years ago. No machine could give you a true circle. You look like you want to could give you a true circle. I bought 4. I printed 4 off on my Solid Doodle. I went with Solid Doodle company. They were originally a engineering company. The gentleman that owned it was from NASA, and he went for manufacturing only, but smaller machines to get smaller parts. So I went with them, having them custom do a machine for me. They also did one for Kellogg's. I basically babysat a machine 24/7 for Kellogg's as it runs. I got my own machine also. I printed off 4 rims. I bought 4 rims from Shapeways. Same thing, same measurements, same everything, same problem. Shipped them to Tom Nunjester, who did a set of rings for me. And he calls me up and he goes, you know, not one of these damn things even fit the thing. Only one does. 3 of them goes right through it, or whatever. They're not even measured right. 0.14 thousandths plus or minus is what you're looking at. tolerance. That's 2 years ago. Now we're advanced. Machines are getting better. Engineering's getting better. Thing is, now we're at a dead stop with a machine that MakerBot system style machine has came to an end that I just found out after ordering an Airwolf HDX3 or 2. But it's the top of the line you can almost possibly get on technology. They're at that point. It's all about programming now. How you can program the machines. When you talk about a circle for rims, the extruder has to try to go in a circle. On a slider bar, it doesn't do that. It goes one, down, back, this way, and it's trying to do a circle, and it's jamming. There's a step problem. So you get half a circle this way, half a circle this way. Sand it down. By the time you sand it down to a perfect circle on your lathe, you have lost everything. Too small. Then we get into 1/25th scale problem. Very, very hard to do on any parts, except the smallest part that you can possibly do is valve covers. That's it. And up. You're talking about blocks, motor blocks, time factor. People think, oh, you can do a block in 3 hours. Not even close, guys. I'll tell you right now, a motor block is not even close. 1/25th scale block is 48 hours. That's at 0.1. That's just a block. 12 hours for valve covers. And that's babysitting the machine, plain and simple. I got up here right now, the main car over 2 years I've been building is the Torino. How many here that likes building with brass? Doing brass interiors, bending, forming? Perfect. That's the best thing, bucks. You guys make your bucks out of wood. There's a machine right now you can do all your bucks. The whole interior was used with bucks I made on the 3D printer. I'm not very good at wood, but I can draw. Machine printed them out for me. I started forming around it just like you would wood, pounded it in. ABS. I know Andy loves PLA. I love ABS. And I'll give you a reason why. The thinness or the smoothness on the top compared to PLA is 3 different versions. This here is basically done at 0.1, wasn't it?
No, that's 0.2.
0.2. Okay, this is 0.2 at PLA. And you can feel the edges. And it was printed just like this. It wasn't printed this way, it wasn't printed this way or nothing. It was printed flat on the bed. The valve covers on this 1/16 scale motor was printed flat up, going up. Feel the top of the valve covers and you're welcome to come up here. They're smooth as glass. That's at 0.08 millimeter. 0.1 ain't much difference, really. It's not. It's just time-wise. The point between a 0.08 to 0.1 millimeter would be the sides. It starts making it thinner, smoother. Don't look at these and say, well, they're not thin and smooth. It's true. These were made to make it here. 1/2 of the block was 72 hours if I was to do it at the right feed rate. I ran it at 180% feed rate to make a motor so people can see it. But the thing is, all the parts on the car that I did use was ran at 0.1 or smaller. The smaller is high resolution. Higher resolution. The smaller you get, higher resolution. Time. You will, if you don't own a machine, you contact me or anybody else, resources, you're not paying for the material. Material's cheap, folks. $80 for 2 pounds of material. I can print you 400 1/16 scale motors all day long out of 2 pounds. That's cheap. For $80, 400 motors. It's time. You're paying time. It's the same. The time pace is being based on, just like CNC machines, $75, push that go button, that's where it starts. Now we're going up by the hour on payments. Drawings, CAD drawings, SketchUp is all I use. I do have Rhino. I use it once in a while if I want to get technical, and I go right into that. NetFab, everything. I'm excited. Like I said, 2 years ago when I got into this, really got into it. A lot of things have happened. A lot of things have jumped. The thing is now the SLA. Me and Andy talked a little bit about the SLA. We brought it up here. It's the resin stuff. You're not going to get the same resin as what Shapeways uses. That's industrial resin. That's hazmat material. EPA is not going to allow you, me, or anybody else with it in our home. But the thing is, it's very pricey. $150 a quart. It takes a half a quart to fill the Da Vinci one. The Noble one was just released last week. That's the one that he said about from Da Vinci. It's $1,500. Takes a half a quart to fill the tank. It's a 5-inch by 5-inch build table. It's not a lot of room to build anything bigger than a 1/25th scale. If you want to go bigger, you're pretty well screwed. The bigger the bid table, you think, okay, it's better. Sometimes it's not. There's one NetFabs just released theirs. I think it was 2 weeks ago. Was it? I think it was 2 weeks ago on the SLA home-based machine. Their build bid table is smaller, $5,000 for the machine. It's smaller yet. So now you're going smaller for more money. But when you get in the resin, you put half a quart in, you have to use that very quickly. You don't have a lot of time to use it up. Okay? So you're basically killing $75 a print. If your print's not right, you got to start all over again. Guys how many here are into resin mastering making for some of the resin companies out here? This is where it helps you guys make money. These machines help you guys. These machines help the casters. Any of the casters are here. This is where it's at. You make the money back. I can do you any part here for $150. How many bodies would you have to sell to make $150 back? But the thing is, the master never wears out. Never wears out. If it's done in ABS, it never wears out. PLA, years and years until it wears out. It still never wears out. Now the master guys make their money, so does the casters, and we all go on. Will it ever, I look at model car forums once in a while and watch them guys go crazy on the 3D, talk about weird shit that everybody's going to have one, stuff like that. They have no clue what they're getting into. Hell, I didn't even know what I was getting into 2 years ago, believe me. I'm excited about it. The more I get into it, the more I do. I have a new machine, the Airwolf's coming in, HDX 3 or 2, and even their engineer told me it's at the end of the line. They're plain and simple. The technology's done. It's going to be phased out, yes. But the thing is, with this machine, I can do exotic parts. I can do the carbon fiber, stainless steel, tungsten steel materials, anything like this on the materials. One of the bad things is it is 0.3 millimeter filament at that end. The resin materials right now is not anything on that material. They're still working with regular resin. But the home-based resin is different. It is 2 different combinations than what Shapeways would use. I'm going to touch a little bit on Shapeways. I know I'm hammering on Shapeways a little bit. It's probably because they gave basically a bad taste to a lot of people who have bought their parts. And everybody thinks, okay, all 3D printers are the same way. It's not. Shapeways, when they first came out, their new stuff is getting a little bit better. Here's a guy from TDR. He owns half of Shapeways. Now, to me, if you own two companies, you should be able to, one, afford over the engineering of $80,000 machines to actually work right and make it where one of your companies is the model business. But he's not worried about that. If you ever got TDR stuff or anything in resin, it's very coarse. It's very bumpy. It's not smooth, plain and simple. You paint it, soaks up paint. You glue it or do anything to it, it soaks it up. You put clear coat. You can use automotive clear. It'll soak that up. It'll still stay dull. And it still stay bumpy. You got to seal it. You have a body. You got to glue bomb it and basically sand it, and it seals the pores. It's a very pore, and it's very coarse. So you seal the pores, sand it down, then paint it. And everything comes out nice and shiny until you set it in the light and it looks like a 1972 Chevy that had 50,000 rust holes in it that's been bondoed over, and you can see the waves in it. Because I don't know how many here, I can't sand a perfect block sand that small and make it straight and stuff. And that's where that problem comes in. I talked to TDR, I talked to the guys at Heartland Nationals over and over. Twister is a very good friend of mine. He does a lot of models, but he has the same problem. And the new product from Shapeways is supposed to be a little bit better. I've seen some of the stuff at Heartland last year, but I have not played with mine. Hopefully somebody here can give some light on it, how to seal it or even be better. But the ABS stuff, to me, is the way to go, but that's just me, because for home use, it's smoother. You paint it, CA glue, 5-minute epoxy. I'll tell you right now, CA glue, you put it on, it seals. I broke an X-Acto blade to separate it. And when it does separate, it will bust one or two of the parts, it will break in half. That's how sealed it is. ABS, you wonder what really ABS is? Look under the hood of your car. Every panel there is ABS material. It's a very strong, sturdy material and stuff. And shrink it down and raise it. And I hope I covered quite a bit of answering. Thank you.
Thank you, Chaz. Again, this is controversial stuff, and you're going to get a variety of opinions. And so ask a lot of questions when we do our question and answer panel at the end. If you would like, does anyone want 3x5 cards to write questions for our question and answer session? Okay. I'm just going to stick this in 2 piles if you just pass them around. We'll go ahead. We're running a little bit behind time, so I want to invite those who have actually had experience and have printed 3D parts and that are in this particular championship to come up. And if you'd line up right here and talk briefly about your part, take a minute apiece and tell us what you've done and what your success and where you ordered your part and how you finished it. So please just line up right over here and... No, you can. I want you to come up, Matt. And as soon as they're done, we'll take a 5-minute stretch break.
Excuse me. I have one relevant question in case people may not come back for the second half. Okay, coming from the Western California area, May 14th and 15th in San Mateo, the Maker Faire. If you weren't aware of it, I'm sure they'll give more information. I wanted to get one question out in case people didn't come for the second half. What representation in 3D printing will be there? I've got a ticket. I'm going, my wife's going, and I want to get other people involved with this, so this would be a vanguard for me getting people there if I know that this kind of stuff's going to go on there, because we don't want to make cute little objects. We're here for the real stuff, so I want to know what kind of equipment will be there, and I can start cutting deals and buying stuff or getting other people involved with this.
I can answer. My shop is across the street from where Make Magazine was originally published. We were the original Maker Shed. We helped sell Make Magazine when it first came out. We've been going to the Maker Faire in San Mateo almost every year. My co-host and I, we usually get there and do the entire fair. Watch for me. I'm going to be there Saturday. All of the big name manufacturers will be there. Shapeways will be there with all their materials. TAM is always there. PrinterBot is always there. MakerBot's always there. You'll see Formlabs. Formlabs will be there. More importantly, you'll see what everybody's making with 3D printing. Last year, there was a guy there that did full walls in PLA. I mean, it's amazing stuff. It's going to blow your mind. Maker Faire currently is probably the optimal place to see 3D printing today.
Thank you. Gentlemen, please say your name and what your project is.
Hi guys, I'll try not to take too much time. My name's Robert Burns, and let's see, this is my item right here. It's a future liner. It's completely 3D printed. I don't want to take up too much of your guys because we're going to be talking about bureau services. The thing with this is that I don't know what the trouble was with Shapeways, but I think it might be the difference with the materials. It just is a matter of knowing which materials and how to use each one. Like, these are SLA, this is SLS, which is the highly porous material that you were talking about. All you really have to do is brush it with super thin super glue and sand that. It takes care of that problem. You could also resin cast it, which is expensive also, but it does save a lot more time. You could sand off the resin casting, which this is. If you guys want to take a closer look, you can. You can see the porousness of it, close up, both the show surface and non-show surface side. Excuse me. Let's see. What resin casting does is it allows you to have more freedom with the materials. So if it's something that needs to be heated up, you could use resin as opposed to some of the SLA, which might warp. You could cast it in rubber, foam. It also frees up your machine. So if you said you have a 48-hour build, take that part off, make molds of it, make castings. You can make 100 more in the time it takes you to build another one. That's also another thing with the service bureaus. It's good because you could pay like this cost me like $4 to order this from a service bureau. And how much time is my time worth? If I sit in front of a machine for 8 hours to watch this build, or I could hire these guys to give it to me for $4, I would rather pay the $4 or the $8 or this. Something like this cost me. These are 3 pieces, and this cost me about $60 to do. I would rather have it come to me and have it done. So also the CAD programs, like something like this. Like, I don't do CAD, so I just hired somebody. I did all the blueprints, reference material, everything like that. I hired a CAD guy off Craigslist, and he was able to make me the CAD program. So some of you guys intimidated by the computer side of it, you don't have to be. Like, I don't do any computer stuff. I just hire out for that. I spend more, but at least I get it done. So that's something that is something to think about also. Let's see. And then I just hire, like, Shapeways or other companies to do it for me. I take the parts, sand them. Let's see what else. One important point that I want to drive home is the fact that I actually got a job doing this as a hobby. So some of you guys who might be like out of work or laid off or anything like that, all the skills that we have as model builders, we could actually use this within the industry. Like the video that we showed earlier, it's like all those guys who take the parts off the machine, like that's stuff that we could do. And I have a full career now. I've been working for about 4 years doing this. So it's like, make pretty good money, and it's like, everybody in this room who has skills, like, you could use your handy skills. Like, this thing doesn't take away jobs from anybody. It actually makes us more important because these are old world old school skills, sanding, mold making, casting, all of that stuff. So I think, if you guys are looking for a new career, that's definitely something you're already qualified, you're highly qualified for. So think about that as a future job. So thank you very much.
I'm Pico Elgin. I'm a member of the Atlanta Club, and I've been doing this for about 3 years now. My design drug of choice is SketchUp. It's a terrific program, and it's a very small part, but on this cord, in the monogram kit, it's a supercharged car, and the exhaust headers go straight out the side. Well, on the unsupercharged car, I designed in SketchUp and had Shapeways print the exhaust headers here, and it's about a, I don't know, $4 or $5 part, not too bad. And so take a close look at that. This is a Auto Union record car. It's printed by Shapeways in the strong, what they call strong white flexible. And the file for this was taken off of 3D Warehouse. I had to manually redo it. It wasn't very well done. There's some parts I had to redo. You turn this thing over and see where it's been printed on the inside. Andy touched briefly on using a photographic, photogrammetric way of making models. This is a 1/43rd model that I took my digital camera to, took about 60 photographs, uploaded them to 123D Catch, and had them produce a mesh of this car. And I took that mesh in SketchUp, SketchUp, and prepared it for 3D printing. SketchUp did, Shapeways did this, and so I have produced from this 1/43rd model a 1/24 scale model. This could be done for full-size cars. I haven't been able to do that yet, but I can see where it's possible to. Thank you.
Thanks. For those of you who don't know me, my name is Matthew Wells, and I own Scale Motorsport. And I want to thank everybody for being here. We sponsored this seminar. It's great to see all these skills and techniques and technology that's finally reaching out to you guys. You will be able to take advantage of this very soon, if not obviously right now. What I did want to show you was the 3D print products that we will have available for you this year. This little display will be on our tables tomorrow in the vending room, which is this room, right, isn't it? And we're going to be introducing a series of wheel packages. There'll be an American torque thrust wheel design series and a billet wheel design series. Each series will have 3 to 4 different designs in each of those series. In other words, there'll be 4 American torque thrust wheel designs and about 4 billet wheel designs. The product will be 3D printed. It's going to come in 2 components. There's going to be a tangible component and an intangible component. The intangible component is the printer code that you can either print out yourself on your own 3D printer, or you can send to Shapeways or to an outside, like Shapeways, an outside printer source. And the tangible part is what really makes the 3D part sing, and that will be the turn metal components that also come with a wheel package. So you'll get the intangible, which is the printer code, and then you'll get aluminum trim rings, you'll get aluminum center hubs, turned aluminum center hubs. You'll also get photo etch details that further enhance all the details on the wheels, and then you'll also be able, where we haven't decided yet how we're going to deliver the rubber tires, but you can also now 3D print soft resin tires, so we'll probably add that as part of the package. So this is a real hands-on 3D printable product that you'll be able to purchase, you'll be able to use with or without having a 3D printer. So come take a look at this today or tomorrow on our vending tables. Oh, one other thing about SolidWorks. It's possible that there may be 1 or 2 U.S. veterans in this room. If you're interested in SolidWorks, anybody that's been honorably discharged, you are entitled to buy the full SolidWorks package, $25. If you've got children in college, they can get the SolidWorks package for $75. And those are two pretty good deals. So if you're interested in that, look further into it. But the guy that did the SolidWorks work for us on our 3D printed wheel package is an ex-vet, and he did it using his $25 SolidWorks package. It's the full-blown package, the one that generally costs about what, $3 grand, $4 grand? Yeah, $25. So if you're interested, look into it. It's a good deal. Thanks.
Hello, my name's Chris Sobak, and well, this is my first GSL, and I don't have my project up here to show you guys some stuff, but it's down on the build table. I'm building a Don Perdome's Army Big in 16 scale. A little bit of my background is I do a lot of SolidWorks work, and I've been doing SolidWorks since 2007. Prior to that, I was doing 3D CAD work in NX and AutoCAD. I'm not real familiar with any of the actual printing myself. I've actually used Shapeways, and how I got turned on to that was buying some TDR parts. And once I first saw some of this stuff, I was thinking, hey, I do stuff for the aerospace industry, making fixtures and tooling, test equipment. And I was going, hey, I can use the CAD software to be able to make some of my own parts, and just out of curiosity, if I can do it, you know, I was sending some stuff to Shapeways, and I can show you guys some of the parts that are on the build that I've done, and some things I was trying to make a little more accurate than from some of the resin stuff I've purchased from Mark Johnson. I don't know how many people are familiar with his products, but he does some good 16 scale engines. But it was just certain things that I wasn't capable of doing myself that I thought, well, let me see if I can, you know, go ahead and make some parts that I'm trying to duplicate and stuff. So I mean, I've been real happy with Shapeways stuff. I've used their frosted ultra detail, but there is a little bit of work, as a few of these gentlemen have said, that you got to sand, primer. I haven't done the method that Chaz was saying about putting the CA on it. I had some good luck just sanding it down and priming it a few times, but it took a little bit of work. But the outcome that I have on it, I was really happy with. So I mean, using them as a service, I can't wait to actually talk to these gentlemen down here, just to see, knowing another service, because I don't know too many of them, but it's something that's pretty neat. And I can tell when Andy had the softwares up there about when he had SolidWorks, AutoCAD. SolidWorks is part of Dassault Systems, and they have a free 2D software called DraftSite. And they used to have, SolidWorks had a program called 2D DWG editor, and AutoCAD didn't like the whole DWG thing because I think they came up with that file extension. So Dassault decided we're going to make a program just like AutoCAD. It's free. It's called DraftSite. You can go to their website, download it, and you can do a lot of 2D stuff. So I'll be more than happy, like I said, to talk a little bit more. I can show some pictures of some of the stuff on my phone as far as what some of the initial prints look like on a few parts. And you know, there's a little bit of money to outsource it, but to me it's been worth the investment and learning some tricks. And the biggest thing is learning the materials and seeing what the parameters that, okay, this material here, here's some of the requirements that they show on Shapeways' website as far as minimum thicknesses. You know, you got different things if you're doing, say, an extruded boss that's coming up, you know, it's got a minimum thickness of, say, 1 millimeter for frosted ultra detail. Now there are other materials that may be 2, and they give different parameters for all this stuff. And then when you upload the parts, they'll actually give you a price. It'll kind of run through a little analysis of your part, and it'll show you the materials that will actually pass, and it'll show you areas that don't pass, what the locations that are restricted of what you can print. So anyway, it's been a good investment for me to be able to use this stuff, and I don't know, it's fun. I enjoy the CAD work and the just trying to see, hey, can I do this? Can I push some limits that I've never done before in the modeling business, and just learning new techniques. And everything. So just thank you guys.
Hello, my name is John Teresi, and believe me, I do not like to speak, so just bear with me for a second. I just wanted to touch on the Shapeways. I also did buy some TDR engine, a couple of them, and I have the models downstairs that I built. And my opinion on them is that they were really easy to work with. I mean, I sanded them down, primered them, and painted them. I even painted them alclad and weathered them, and I think they came out really good. I mean, I did some modifications to some of the parts, but I can't do like brass or milling or lathes or anything. So for something like this to come out with the detail that it has, it's just unbelievable, and I think it's the future. I really do. I mean, it's awesome. You know, that's all I can say. Sorry.
Hello. Anyway, my name's Gary Kolchak, and why am I up here? I don't do 3D. I've had a motor printed for me. I do 2D, photo etch work. But I have a friend, TDR, Tim Floyd. Lives about a mile from me, works with me. I've got a model downstairs on the primer table, 300ZX, that I've been working on for 23 years now, on and off. But it will get done. Anyway, I had a nice Nissan V8 engine I was putting in this thing, and Tim approached me probably about 6 months ago, and to do a little advertisement for TDR, he asked me if I'd drop one of his engines in my car. And I said, no problem. He says, well, what do you want? So I put a 572 twin turbo, twin intercooled motor in a 300ZX. The motor's sitting up here, all 3D printed. And it looks beautiful, it really does. It was done in the frosted high detail of what these gentlemen have over here. Some nice stuff. Anyway, it'll be downstairs, you can take a look at it. TDR primarily got started doing the 1/12 scale, 1/8 scale type engines, bodies and stuff, and they've got a huge product line. But they're trying to get more into the 1/24 scale now for all you guys. So take a look at it downstairs.
Thank you. Let's give these guys a big hand. Okay, we're going to take a 5-minute stretch break, and believe me, the best is yet to come. The best is yet to come, and I truly mean that. We're delighted to have White Clouds with us. They are a Shapeways affiliate, and you know, we did something really unique here in Utah. We have two model car clubs, the Utah Model Car Association and the Utah Miniature Automotive Guild. Take a tour of White Cloud's facilities in Ogden, Utah. And our good friend Dale Angel documented that tour, so we're going to show you a video of the White Cloud's facilities right now.
Well, we've got an interesting little...
Thank you, Dale. That was great. Okay, so my recommendation is that you go see a 3D printing service bureau in your area, and they'll be happy to give you a tour. Do that as a club or as a group or as an individual. So it's now my pleasure to welcome Carrie Parker and Chris Flowers from White Clouds, and they're going to share with us what their service is all about. Oh, a couple minutes. I need to mention that we've got extra time, so we're going to take the time we need to do this.
It's Friday afternoon. Extra time. Yeah.
I'm so mean.
We're excited to be here, and I'm most excited to see that other people are excited. I don't even know Ed, and I'm like, we need to know you.
Oh yeah, you do. You want to get on the show?
Yeah, we're going to talk to you about that. So White Clouds started a couple of years ago. The owner of our company had this idea that he wanted to take 3D printing to the masses. So we got this company going. He bought some printers, industrial printers, and we're set up, and we thought, man, we'll launch a website with a million zillion parts on it. People will go nuts. And guess what? It didn't work that way. People are not ready to run out and just say, ooh, I want to 3D print this or that. Now, whether it's they're not ready, they're fearful of it, they don't understand it, in what Ed talked about here, there is a lot of unknowns about 3D printing. You can buy your own printer. We highly recommend that, to buy a printer and do it yourself. But if you're not up to buying a printer and doing your own thing, it's possible to outsource that, and that's what we are. We're considered a service bureau. Now, Lynn said we were an affiliate with Shapeways, or we're not. We partner with Shapeways, is the way I'll put it. Shapeways approached us to outsource their printing to us. They don't own a lot of printers. They outsource a lot of their printing. You probably didn't know that, but if you've done any printing with Shapeways, there's a good chance that we probably did that here in Ogden, Utah. We print for them in just a couple of different, so we've got the Stratasys Connex 500, it's a PolyJet technology. We also have the 3D Systems ProJet 3500, which is a multi-jet technology. Both of them have UV cured resin. And so a lot of the parts we do for them, we do for modeling and that. There's also another company in Pennsylvania called 3 Delivered. And if you want to write it down, it's 3delivered.com. They do a lot of model car, model train, miniature parts, and we do all the printing for them. One of the problems with the service bureau, so we have a $15, $14.99 minimum. You bring a little engine to us and say, print that, you're probably not going to want to pay $14.99. But if you brought a lot of parts, and that's what a Shapeways does, or a 3 Delivered, they bring that to us, and then we can print all at once. So the technology, we set this up so that, because as you heard, it isn't just a plug and play. A lot of people think, oh, I can buy a printer and I can just push something in and it'll print. And it's not quite that way, as you heard earlier. There's a little bit of mesh that has to go involved, you have to have some designer capabilities, or you go on like a Thingiverse and download a file, and that's not even a guarantee. I've downloaded files, you get them, you go to print them, and they turn into a blob. So, yeah, it's not always the best way to go, but you can. I tell people, I have a GoPro camera. I wanted the bracket that holds the camera on the handlebars of my bike. You buy that in the store for like $20. I downloaded that from Thingiverse, printed it on our MakerBot. Cost me like $1.25 to do that. So that's the kind of thing I think you're going to see as more and more people get consumer printers. If you have a printer in your home, I know that somebody said, yeah, people are saying, oh, everybody will have one. It's like a microwave. And I don't know if that's ever going to get to there. I do know, I can tell you, as far as medical technology and 3D printing, I know this has nothing to do with what you all are doing, but it's intriguing to see. There are companies right now, one in particular in California called Organovo, that's doing the research and development on medical, where they will take DNA from a person's body, they will take that DNA and print with flesh and print a vital organ like a heart or a liver, and they will transplant that into a person, and instead of rejecting, it's built with that person's DNA, so you won't have the rejection rate that you do with an artificial heart or liver. They're saying that's within 10 years. We'll see. I know there's a lot of hurdles there with FDA and AMA and all of that stuff. So, but 3D printing, I'm so happy to hear you talk about it and the enthusiasm, because in the 2 years that Chris and I have been in it, we've seen major changes. 2 years ago, we had a booth at CES. There were 27 3D printing companies there, and that was companies that were with the small printers, the big printers. This year, there were over 54 booths there in the 3D print zone. Next year, it'll probably be close to 100. So the technology is growing. I think for what you're doing, you're going to see the capability, design capabilities. That's one of the things that we specialize in. If you need design, something designs, we have about 10 designers on staff that can help you with your design. You can go outsource that, hire somebody off Craigslist, whatever. Just to mention, if some of you are designers and are looking for some work, we outsource some of our design work, and we'll be doing that in the future. So you might contact us for some piecemeal work that way. Chris, anything else that I'm missing here? Yeah, $14.99 minimum. One of the things that if you came up here and seen one of our machines, it'll print multiple materials. So that there, it's an Apple, the iWatch. It's not the real thing, but a marketing company had us do 15 or 16 of these that we did as prototypes so that they were testing the wearability of it and how it would feel on a person's wrist. So we had to get the shore value of the band exactly, and that machine, that Connex 500, will do 6 different materials at the same time. One of our other machines, it does sandstone. That's the one that prints, that Dale had on his video there. Prints in color. The downside of that is very fragile. If I drop that, it's probably going to break. It's more for looks, and that. We do a lot of architectural models in this material. We have right now 8 machines that print this stuff. ProJet 660s that we print this stuff on and do a lot of this. But the only way to make that strong, and we had one little, you coat this with a resin, and that, you can throw that down, it's not going to break. Yeah, right. It's just my luck that it breaks. When we're done here today, if you would like, we're going to just leave all of these parts other than the bigger parts for anybody that wants to take, it's a sample. We do a lot of overruns when we do shapeways. If they don't come out just right, it's the bad thing about 3D printing, and you'll vouch for this. It gets to the end and you go, oh great, and then you start looking and go, oh, that little part there didn't work. You can't, it's hard to fix it. You about have to start over. So that's the downside. But other than that, yeah, we feel that 3D printing is here to stay. It's not a flash in the pan. The technology is going to be just bigger and better every year. So yeah, feel free after, take one of our brochures and check out our website, and we'll answer any questions you have. Do you want questions now? I'm going to do that later.
We'll do questions later. Thank you, Carrie, very, very much. Thank you, Chris, for being here. So 2 years ago, we introduced the Venapart RigidBot Kickstarter campaign, and several of you purchased, I think there were about 8 to 10 people were involved in that campaign, and they had their difficulties, and eventually they did deliver, and Don Henriksen did get a RigidBot, and he's going to show us how we use it today. So we've got a live demo, folks. Take it away, Don. Thank you.
Better? Is there? Okay. Never done this before, so obviously. Yeah, obviously. My name's Don Henriksen, and I'm going to go at this from a more practical standpoint. I've never owned a printer before. I got into the rigid bot campaign and bought the thing, and I'm going to admit I had my problems with it. It wasn't a perfect machine. Personally, I think that the design was very well done, but I think their Chinese build of it was pretty poorly thought out. Yeah, pretty poorly thought out. How come this is working? What did I do wrong? Wait a minute. Sorry. So let me give you a real quick about myself. I grew up in the 50s and 60s as a kid, so it seemed like every 2 weeks somebody was coming out with 1,000 models. We put them together, the glue specials, you put them on the shelf. 2 weeks later, your mom picked them up, dust them, and all the parts fell off, especially the chrome, because I'm not going to scrape the damn chrome off. And then you go back with your allowance and you buy another one, you bring it home and do the same thing. So pretty soon you've got a whole bunch of crap and it ends up in the junk box, and now the stuff is worth a bloody fortune. So, as I strayed away from model railroad or from model cars, I started doing other stuff. I kind of got away from it for a while. Then when I came back, my skills were better. I could actually afford stuff. I went out and bought lathes, mills. I kind of strayed away from model cars. As Mark would say, I started to the dark side. I started going to model trains, wooden model ships, model cars, doll houses, you name it, and I did it. So there's one of my latest brass models. These are chunks of brass. You got to machine them, you got to make them work. They're not an easy thing to do. So let me kind of blow through these really quick.
What scale are those?
They're O scale, but they're narrow gauge.
ON3.
Yeah, exactly. Yeah. So there's the painted. Here's a 2.5 year project I did. It's a 24 scale gondola that I did. It's turned out pretty well. Let's kind of blow through those. Okay, so after he's talked, I'm going to kind of blow through these because you went through all these. I see 3 major types of the models, or of the printers. I see the polymer. When the University of Utah bought their first polymer printer, they spent $500,000 on that thing. And the goop that poured in there was like $150 a gallon. So, needless to say, you had to have somebody special before they'd let you print on the thing, or even print something on it. The ones I see now are the cornstarch, where it spreads the cornstarch and goes back and squirts the stuff on there. Those look okay, but they're super fragile. If you pick them up, they just kind of disintegrate. And then the one I think that's going crazy are the plastic wire printers. What I don't know what people else call them, but I call them plastic wire. The companies that are coming out with them, Micromart has got one out now, Dremel's released one, Zenekinetic has got one, Rigid Bot has got them, and he named about 50,000 more that I didn't even know of. So I'm going to kind of go through the parts really quick. The major parts of that one are the chassis, which holds the thing, the X and Y steppers and Z steppers, the bed, the digital controller, which he said is Arduino based. I don't know if you can get any on Arduino based. It's an amazing controller. It seems to be pretty flexible. I'm assuming that Richard Bach probably had to design the car to put the drivers in there to drive the motors, because I don't know the Arduino comes with that. And then the power supply. There's the plastic materials. There again, he went through all this, so I'm just going to kind of blow through them. When we print this, you won't even be able to smell the thing. It doesn't have an odor at all. It doesn't warp very much. I've not printed with ABS, but I've heard it's got a stronger odor, and I've also heard that it almost requires a heated bed because as it cools, it warps. So, not wanting to have it warp. Okay, so with this, I had to have 3 software packages. And what's nice about these is they're all open source, with the exception of the 3D modeling software. I had to have the 3D modeling software, which is expensive. I checked on a license, a home license of SolidWorks, and they told me it was $4,500 plus a $1,250 a year subscription fee. That's nuts. Solid Edge are great people to deal with. If you have a commercial license at work, they allow you to have a home license. All you got to do is sign a non-commercial agreement that you're not going to go out and make a bunch of money on the thing. For somebody like me that just does it for fun, it's great. Solid Edge, SketchUp. SketchUp used to be owned by Google, but they've kind of sold it to somebody else. I think it's owned by a company in Europe now, a German company or something. And then Autodesk Inventor, he went through that. The slicing software is, I started with Cura. There again, it's free, you just download it. I'm using KISS Slicer now because it seems to have a little bit of an advantage. You can actually do the setup files in Slicer, and when it downloads the Slicer code, it actually sets your printer, your extruder temperatures, it sets the printer speed, sets the bed temperature. So it's really, really, really nice. One thing, on the output of your 3D modeling, you're going to either output an STL file or an STP. STP, I think, has kind of fallen by the wayside. I think most people now are using the STL files. The slicing output is G-code, and that's what actually sends to the printer. Is just, if any of you are familiar with any kind of machine shop, any CNC stuff, that's all G-code. It's exactly the same. The only difference is that they've gone in and they've kind of standardized on a format that there are certain G-codes that apply to 3D printers. Like the extruder, I mean, how would you possibly, there's no way you could do that with a mill or a lathe. So they've had to go back and add their own special stuff. Oops, wait a minute. Oh, no, that's not supposed to. Okay. The slicing software has got some really nice stuff. If you have overhangs or if you have some kind of a bridge, it'll actually go back in and adds that stuff automatically. You don't need to deal with it. When you get it all done, they usually do like a little tapered thing at the top. Just snap it off. It's just cool as heck. So what you want to avoid is an overhang. If you go less than 45 degrees, it's going to want to build an overhang. If you go more than 45 degrees, it'll be fine. A bridge is where it tries to build over top of itself. Obviously, as you're building that, it can't print out into open space, so it's going to try and sag. So there's where it adds the supports. It automatically does that. Cura does that. Slicer does that. Then the direct digital interface or printer interface, and this is actually what talks to the Arduino. And so what we've got is, this is what I use. He was suggesting another one. I have to talk to you about that and see what it is. This is called Pronterface. It's free. You download it. It's the greatest thing in the world. As you can see, what it's got is it's showing the controls for the X coordinate or the X coordinate of the head, the Z, and the Y, and you can actually go back in and make the thing move around. If we tell it we want to go back and say, oh, geez, we want to go to the X home, you push it, and it just takes off. Oops, that's a joke. Oh, there it goes. So as you move it, you can actually go in and you can tell it you wanted to make it go up, you can make it want to go down. And I don't know if you can see it or not. I don't know if you can see it or not, but as I move it, it's actually yeah. So it also gives you the temperature of the head. This is the extruder temperature. This is the temperature of the bed. I've had horrible luck by not having heated beds. I would recommend, if you're going to get one, to make sure you get a heated bed. Okay, so let's say you're going to go buy a printer. He had some really, really good ideas. He's more experienced at that than I am. If I were to go buy another one, you would have to decide what you're going to do with the output. You're going to sell it? You're going to use it for modeling like we do? Or are you going to have it cast in brass? What are you going to do with it? If you're going to, I've talked to a couple of people who do brass casting, and they actually said that if you want, there are certain plastics that you can use. You can just send it in, do your 5% over, it automatically, they throw it in the mold, they don't have to do any wax stuff, burns the plastic out, and you get a perfect casting out of it. The cost of the printer, of course, the size of the printed parts. If you're going to print a car, there's no way you're going to be able to use that. So if you're going to do little stuff like I do, this size of printer is great. What kind of features do you want it? Do you want to do dual extruder? Do you want it? I would recommend a heated bed. If you want the Z coordinate, you get a finer threaded rod. When I bought this, I bought the updated threaded rod, so this will be pretty fine. And then the interface to the computer. This one, I prefer using the USB. I know some people like the little SIM chips. The only problem with the USB is if the cable gets screwy, sometimes the printer can, or the computer can reset itself. If that happens, you got to start over again. I think that the SIM card is probably a little bit better for that, but I don't know that the SIM card is as easy to go in and change the codes. With this, if I want to slow part of it down, I just go ahead and give it a code that slows it down. When I want to speed it back up, I give it another code and it speeds it right back. And I don't have enough experience with the little SIM card controllers to know if that's really true or not. You want to buy a kit? I bought a kit, but I'm dumb. I have no sense. So I tortured myself and bought a kit. Again, his recommendation of which ones to buy assembled, way, way better than what I did. I did it the hard way. You also got to look at the support. Are they going to give you support once they think if it isn't working, you're going to be able to go back and talk to them and say, "Gee, you did this wrong." Or are they going to offer classes if you have a brand new printer, for a brand new printer person like me? What about the parts? If the company goes toes up, you're going to be able to get new parts for it. If your extruder heater goes bad, what are you going to do? If it's exclusive part, you can't get one. You got to make sure that all the stuff they use, or at least most of it, is a standard part. The stepper motors, the extruder tips, the extruder heaters. You can just buy it from anybody. So don't, like he said, don't go with something that is going to lock you in to their printer parts. When you go out for help on the internet, take it with a grain of salt, because you're always going to find somebody that's got an axe to grind. Go out and look at various sites. If you see the same stuff coming up time after time, it's probably not a good thing to do. The location of the printer. If you get one of these things, where are you going to put it? If you got a house with little kids, you're going to have little fingers in it, whether it's running or not, and that's not a good thing. Do you want to have a dedicated computer for it? Do you want your kids getting on the internet and downloading some virus while you're trying to print 16 hours into a part? Probably not. The odors, you want it out of the way. You don't want it in the middle. You don't want it on your kitchen table if you still want to stay married to your first wife or your second wife. She's not going to be real happy if she goes to serve a nice dinner and there's her printer. I'm only halfway done, dear. I got 20 more hours before it's finished. And then the odors. If you got somebody that's sensitive. I've never printed with the ABS. I've always used PLA. And PLA, I can't even tell it's even running. Software. There again, to avoid proprietary anything. There's so much open source now that you don't need to have proprietary. I'm sure that in the future it's going to happen, but right now it's not. Okay, so here's where I have mine. It's kind of a mess, but it's back in the corner. I've had really good luck with it. It runs great. It's quiet. I don't even hear it running. I don't leave the house when it's running because I'm a little bit nervous about something happening. Okay, so now you got your spiffy new computer. You talked your wife into buying the thing. Now what? You got the boxes sitting there, you open them up, and you go, wow, this is really cool. So if it's a kit, check for broken parts, and make sure the whole thing is there. If it's a kit, you got to make sure that it's all there, make sure it's not broken, ensure everything is in there. If it's got instructions, follow those by all means. The rigid bot did not. When I built that thing, I was pretty much on my own. Plug in the USB, power the thing up, make sure all the fans work. Don't want to do anything without all the fans working, because if you don't, you're going to have some problems. Make sure pronto face moves the axis smoothly. Make sure that it isn't jerky. If it's jerky, stop and fix it. Make sure all the physical limit switches work. Ensure you've got the full X direction, the full Y direction, the full Z direction before you do anything else. By the dress the wires, this one, when it goes up and down, has a bunch of wires. We want to make sure that when it's going up and down, it's not going to grab the wires aside and tear the whole thing apart, because that's not a good thing. So you want to make sure that's all going to work. Move the Z-axis to home, check the height above the bed. This is super, super, super important. Don't blow it off. He was saying that they got a brand new one now that auto height, that's the greatest thing in the world, because that one was a pain. So go ahead there again, go to the manufacturer, what they recommend. This one recommends a piece of paper between the bed and the nozzle. You want to just pull it through smoothly. You want to adjust all four corners. So there's the tip, there's the distance. You want to just make sure that whatever they specify, I don't know that the paper is a standard thickness, but with the rigid bot it is that pretty much everybody uses. And then what you want to do is you want to go to all four corners. There again, when you're going down the first time, be really careful. You don't want to drive the tip into the bed. Doesn't do the bed any good, doesn't do the tip any good. So go really slow, kind of keep an eye on it. Printing your first part, wow. So pick something simple. Don't pick, what thing we downloaded the first time was a head, right? It killed the computer. So we finally ended up printing a chocolate bar. Where's the chocolate bar? We downloaded the chocolate bar, printed it. Here's the chocolate bar we printed. Really, really simple. Took it about 20 minutes. When you want to make sure there's no undercuts, no bridges in it. STL file should be about 200K. If it's any bigger than that, go someplace else. Check your time on pronto face. If it says hours, it should be 15-20 minutes. Cover the bed with 3M blue painter's tape. This one I've replaced with glass because I didn't have as good luck with the painter tape as everybody thought I should. Ensure the bed and extruder are at temperature. Now on this one, as you can see, I don't know if you can see the little lights blinking underneath the bed. That means that the bed is at temperature. And then you can tell by up here that the extruder's at temperature. Because it has to have a medium, you don't want to put the part right on this is aluminum. You don't want to put the part right on the aluminum bed. If you put the painter tape down, it peels off, it's easy to replace. When I was doing it with the painter's tape, I was only having to put new painter's tape down like every 3 or 4 parts. I quit using the painter's tape because I was having problems with the parts breaking loose. So when that happens, well, where's the rocket pad? This is what you don't want to do. I tried to print, the little rocket that Dale's got on his website there. Well, I tried printing him a rocket, and it got about that far, and I went in the other room to do my business. And I came back, and this is what it had done. So after this was the last painter's tape one I did. Insert plastic wire and use pronto face to extrude the wire out. When it comes out, it should just pour out of there. You don't want a little wimpy stream. You should get a really, really good, because otherwise if you don't, it's going to stop halfway through. Watch it closely. Don't go away from it while it's printing the first part. Let the part cool and peel it very carefully off the painter's tape. Tell your wife that maybe the $3,000 you spent wasn't such a bad investment after all. Kids don't need to go to college, right? That was just their idea anyway. Okay, now here's the problems I've had. And all this stuff that I've done the hard way. I've learned it by going and talking to people, by experimenting, by learning some and making up some new cuss words. If the part breaks loose from the bed, it usually means that the part isn't stuck down. And usually what I've had good luck with is either raising the temperature of the bed so that the plastic hits the nice warm bed and it sticks. There again, I'm sure his experience is probably different.
I have a lot to tell you.
Oh, good. I can use all the help I can get. Or you can turn up the bed temperature. Don't go in and change a bunch of stuff, because all you're going to do is if something works, then you don't know what worked and what didn't. So run a part, turn up the bed temperature. If it doesn't work, maybe turn up the bed temperature some more. This one, the bed temperature, I think they recommended 180 for PLA. I'm up to 210. I've had pretty good luck with 210. The bed temperature started at 60. I've got it up at 70 now, and I've had pretty reasonable luck. I replaced the painter's tape with glass. If you put glass on there, readjust your height from the bed to your tip. You don't want to be driving the tip through the glass. It won't do the glass any good, and it's not going to do the tip any good. When I paint the bed, I paint it with, where's that? So I put about, this is about a pint, and I put about 3 feet of ABS in this. And I let it sit overnight, it gets good and dissolved. And what happens is if you paint it on the heated bed, it immediately, the acetone evaporates, and you got a nice good sticky coat of ABS on there. And man, it sticks like grim death. To reset the extruder temperature. Slow down the printer. What I do with these sometimes is when you use Cura, it sets a speed. What you can do is you can actually give it what they call an M code 220. You can slow the thing down. So what I do is for like the first 1/8 inch, I'll slow it down to 40% and just let it go really, really slow. It runs around. It gets a really nice, good, stable platform. And once you get up to about 1/8 of an inch, crank the thing up and let her go. And I don't usually run it over 80%. I'm in no hurry. Okay, you can see the glass bed, and it gets it looks like somebody snowed on it. And if you keep doing this, don't scrape it off, don't have your wife clean it because it's ugly, because she's going to ruin it. What happens is the plastic gets into the pores of the glass, and it really grabs on. So when you get that snowy look on there, it's perfect. If the part warps during the print, slow the printer down, turn up the bed temperature, or just flat out redesign the part. If it stops extruding plastic, which it will do, you'll get about, maybe a couple of 3 minutes into it, and you look down and the head's just going around, it's having a good time, nothing's coming out. Invent a new swear word, stop it, go back to the beginning, peel the plastic up, start it again. Make sure you got a good stream of plastic coming at it, and start it again. If the slices are too thick, if you're getting too thick apart, cut the slices down. This one I've got set for about 0.1, and I've had really, really good luck with 0.1. The realistic expectations, well, these guys have just completely blown this slide out of the water. I was told that you couldn't get anything below about a 1/2 inch. So you can't print a 24 scale carburetor that I could see. Part complexity, I don't go anywhere between line thicknesses of 10,000ths, line heights of 10,000ths. I don't go any more or any less than like 20,000ths for an unsupported column. The repeatability, you're not going to get, you're not going to be able to use the same part. If you're going to go into a commercial process, you're going to have some kind of a tolerance in the part. Expect it. It's going to be a pain, but it's the way it is. Supposedly there was a durability of PLA. It was supposed to be dissolving. I talked to people there again. They said they've got PLA parts they've Had for 10 years, they look great. If you're an outdoor railroader, don't print the thing and put it outside because it's not going to last unless you want to put a good coat of paint on it, use Rust-Oleum or something. STL sources, be careful. You got it off the internet, it has to be good, right? Not true. When you print a part, when you take a part off the internet, take it with a grain of salt, because not always does it print. So when you're designing your part, don't print something like this because it's going to put supports in there, and if you don't want the supports, you don't need them. So what I do is I just turn the thing upside down, let it print flat on the bed, and that seems to work out a lot better. So where are we headed? This is Swami Don. I'd have the little hat, but I forgot it. It's at home. The way I see it, I think everybody's going to have a 3D printer. I think you're going to have a microwave, a PC, and a 3D printer. If your kid wants to do a Pinewood Derby, you don't go to the Pinewood Derby store. You print the damn thing out. If your wife wants a new cover for iPhone, you just put in the flexible plastic, print her out a new iPhone. Great way to spend an evening with a son or daughter. The intellectual property, to me, is not in the part. You know, when you bought a plastic model years and years ago, the intellectual property was the plastic model. I see the intellectual property as the STL file. I think when you download those, I think that's where the real value it is. So let's say you find something you like, you shop over the internet, you pay the guy directly that designed the thing. So he's getting the money. It's not going through 81 middlemen before he sees it. Download the STL. If you want to go back to him and say, well, you know, I like my wife's iPhone cover, but she's got a little extra thing in here. So we can go back and adjust the STL file and send it back to you. Huge possibilities for do-it-yourself. If you have any kind of CAD experience, man, I think that this market is just going to be huge. I think there's going to be a lot of people doing it. All you need is a PC, 3D software, and internet access. Got an idea? Don't pay Ronco, pay do-it-yourself. So what am I using it for? I have, as I said before, I've got some ON3 engines. The latest thing now is they're using a sound system in there. Well, the speakers need a baffle because if you don't get any bass out of them. So what I'm doing is I'm printing the baffles. The really good one. Okay, there's the baffle that we did. Here's a pot car hopper that we've been talking about doing for years. There's just no way of doing that thing in plastic. There's just no way. So I did it as a 3D file. And there's the one that Al's doing. Printed the thing out. Turned out beautiful. Did a Christmas alignment. We have a 3D printer store in Salt Lake now. It's called ZennyKinetic. They're amazing people. They have plastic. They have printers. They've helped me with a bunch of stuff. Oop. So my last words are, don't give up. You buy the printer, it doesn't work, don't throw it away, keep trying with it. And then my next advice is play, play, play. Change stuff, change printer wires, change speeds, change anything you want, change 3D files. Okay, so now let's see if we can get the thing to work. Yeah. So what I've got is I've got a really, really simple part. We're just going to load it. We're going to do the bottom of the baffle. So what you see it loaded on there. What we're going to do is we're going to return the printer back to all of its homes. So we'll just go here. I don't know if you can see it or not. Yeah. Then it goes back to its home. It sets the bed down. I'm not going to extrude the plastic because we're just going to see what it's going to do. It's been hot here for about a half hour, so we're just going to go ahead and start it and see what happens. So all you just do is you say print. So it sits there for a minute, decides what it's going to do.
What's the purpose of all the flashing lights?
That tells you the bed is hot. That's just something that Rigid-Bot did. So what this is the temperature of the bed, which is the top one. Or I'm sorry, that's the temperature of the extruder, and the temperature of the bed is down below, and I don't know why there's a fan. Oh, there it goes. So what it'll do is it moves the head up, and it takes off, goes to the center. And what all the 3D printers do is they actually go an outline around the part just to make sure the extruder's working. So then it'll start doing this inside of it. You can tell how quiet it is. You can't even hear the thing running. So it's not going to be louder than your kid's iPhone or his iPad.
Have you got a lot more to say?
Nope, this is it.
Wow. We thank you, Don. Did that get your attention? Yeah. So we'll leave that running for a while. Now we're just about ready to wrap up, and I want to give a big round of applause for all our presenters. Just awesome. Does GSL deliver or what?
Yeah.
Okay, so we're really out of time. There's a video on the future of 3D printing. If you'll go to carbon3d.com, you can see that. We won't show it. It's a short video. But I do want to invite you to take advantage of something really new. If you like 3D printing and you want to explore it as a model builder, there's a new website. I'm putting it together. It's in beta. It's not polished, but you'll get the idea of what we can go. And I invite you to sign up for it. Could we show that that screen? In the upper right corner, there's a sign-in page, and you can become a member of it. And what the areas are, on the left corner, there's a video. If you like the Miller race car video, you can watch that there. There's a sign-in on the upper right. We've got a tour, the gang, a blog, a showroom where we'll show 3D printed parts. You can contact us. There'll be events like contests. There'll be a forum. A shop manual will be a listing of CAD software and slicer software and thank you, and different things. Toolbox. There'll be challenges, like if you want to participate in a project to be challenged, and then also get gear. We'll have some connections with the online sources for you. And again, it's in beta. It's not fully developed. It's kind of like a placeholder. But if you want to get more information on it and support us, Andy's going to be involved. Chaz is going to be involved. We're excited about this. So go ahead and go to that site and sign up. So again, thank you. If you have a 3D printed part in the contest hall, please come see me. I've got a little tag to put by your model, and we have little post-it note so you can jot down what it is you 3D printed on your model. But please do that. If you've got a 3D part, come up and get it. Please come up and get your parts. And if you have questions, you're welcome to stick around, but please clear the area so they can get it set up for the museum seminar. Thank you.
Make sure you put next to the funny car.
Seems like those who are here.
I know.
Absolutely. How many guys are at this table? What if you wanted a big scale?
Some of the materials are used the same, like the frosted alternate.
Looks like it's got a wooden carriage.
Is this the Star Wars X-Plane?
I've heard
Except for the part where the pilot sits. Yeah.
Well, yeah.
I saw that advertised that like last week.
Yeah, then I was going, oh, they said frosted details going on.
I like this rack of airplanes. Now that's an
interesting
interesting way to do it.
This is 3D printed?
Yes.
All the frosted stuff.
We fill them on aircraft.
So yeah, it takes the exact same materials.
Yeah.
It's a setting on it.
See, I'll clear out.
Yeah, I mean,
There's no need.
That's what you're cutting. You went down. Oh, that's right. It's after.
I mean, there's some stuff, honestly, design.
Yeah.